setup, but they work in Google DeepMind. DeepMind is, the part of Google which, develops a lot of tools and then a lot of tools and then a lot of hardware platforms for applications of AI into the mainstream. So they have devised artificial intelligence in order to predict what are all the protein, characteristics or prediction, protein structure. And it's very difficult because manually one cannot do it, and one has to go and use chemistry. And they are computer science specialists, but there is also somebody who is a specialist in protein structure prediction, who is basically a chemistry person, and they have been awarded with, the Nobel Prize in chemistry. So I would just, well, this is basically a bird's eye view of what are all the possible things which one can do in artificial intelligence and what are all the drivers, because I've been associated with electronics and computing maybe from 30 years, and I've seen the progress of, how we have led to, from electronics, electrical and mechanical engineering, etc., to computer science and later computing and later to artificial intelligence. So basically I will just touch upon what are all the compute drivers which have posted this big thrust in the area of artificial intelligence. It's semiconductors, and especially India has given a lot of encouragement to semiconductors. And especially our Prime Minister has got these schemes called PLI, DLI, etc., which are program process linked incentives and design linked incentives, and he wants a lot of fabless semiconductor companies to come up in India. So that's one thing. And there's a lot of, especially I come from Manipal, and Manipal has got about 7 or 8 fabless IC designed semiconductor companies in Manipal, and that's all in the last 2.5 decades. And we have seen lots of processors also. I have seen the processor of, central processing unit, and then there was a microcontroller unit which was specifically doing some tasks such as controlling certain systems, maybe washing machines and TVs, etc. And also I've seen the progress of GPUs, that is graphical processor units, which were all basically, nobody thought of the compute power of these GPUs, and they were mainly using it for playing games, right, graphics. But later they saw that it's very compute intensive and it's very computationally very powerful. So they started using it for all kinds of computationally difficult problems such as weather prediction, whether it's drug prediction, and artificial intelligence and so on. And one of the advantages of digital technology is that its programmability. You can program it to do the things you want it, right? Unless analog electronics, where you'll have to tweak all the electronic circuits and so on. So you just change the program and their behavior will change. And we have seen lots of sensors, lots of transducers where, different modalities can be sensed and then converted to electrical signal, and then you can take information into your system, and then you can build systems on top of that. And there are many biologically inspired sensors and transducers also, like microelectronic, electromechanical systems and sensors and so on. And these days it's not very difficult. One can just do this MEMS design and then fabrication in a laboratory setup only. And compute tools, whether it is cloud technology, one doesn't implement all these AI systems, which I was here part of the system in the morning, and I saw that lots of applications of AI, whether it's agri-tech, whether it's med-tech, whether it is security system and so on, all of that can be implemented on your laptop, on your general purpose computer, but one can also implement all this on the cloud technology. You needn't invest anything on your hardware, or anything needs to be plug and play. Everything can be on the cloud, and then that's an advantage. And there are lots of compute tools, and lots of newer companies are coming up with lots of tools. And there is this concept called Jupyter computer, and also through browser, you can run many of the artificial intelligence projects like Google Colab and so on. So these compute tools have helped a lot, especially for the AI algorithms and then, systems to be penetrated into all our pedagogy, all into the education field, and also so that all the students can utilize this and then they can implement and so on. And internet, the CEO of Google, Pichai, says that just like how we need food and water and shelter, internet is also one of the key things which one needs. And data is another thing. And in the morning we saw lots of questions were being asked about from the session chairs to the presenters as to what is the data, how did you collect the data, and then when you collect the data, you have to have lots of ethical clearance if it is medical data. So we work a lot of, because we are associated with a hospital and we collect a lot of medical data. So we take a lot of ethical clearance, and then we make sure that the data is clean and structured, etc. Right? And the humongous growth of a large amount of data, whether it's electronic commerce, whether it's medical technology, has paved its way into applications of AI. Okay, I'll just touch upon, because I've been associated with this field from the very beginning. So some of the machine learning applications are, supervised learning. So where there is a supervisor, so we are all used to supervisors who suggest or give feedback as to show what is the area in which we have to trade or traverse. So there is supervised learning. There is somebody who nudges our way whenever we get drifted. There is unsupervised learning. There is no supervisor, and then that's also a part of the machine learning. These are all the different types of machine learning algorithms, and this is used in customer segment. So some of the customers who come to your Amazon or come to DMart, what kind of things they will buy and what kind of things they will buy on the festival season, etc. Such kind of a segmentation one can do using this unsupervised learning. So it is only segmenting of the different customers so that you rack up, you keep in stock, so that your customers are not served better. Semi-supervised learning. So it is there is a supervisor, but there is also no supervisor. It's basically no supervisor. At the end, a supervisor comes in, and then some of the basic things he just tells you as to what are the classes, what are all the different ways in which you have classified, and so on. So semi-supervised learning. And reinforcement learning is another thing which learns about the environment in which it is working. There is it's called an agent, and then there is a feedback, and that the feedback is positive if it is rewarded. If the agent is rewarded, then it's positive feedback, otherwise it is negative feedback. Okay, these are all some of the areas of artificial intelligence. Data classification is one, and we saw in the morning. I will not go into all this. That's a supervised learning. So there is a supervisor who labels the training data. You have to train the different systems, whether it's SVM or whether it is a neural network, whether it's an artificial neural network, or whether it's a LLM, that is large language model. So there has to be a supervisor or a teacher who has labeled the data and then tells you as to how do you train that. So that's the data classification problem. And there is a data cluster. There is no supervisor. There is no labeling. So it's just the data, and you group all the data into different clusters, into different groups, like customers I told you. So data clustering is another technique which is very much used in machine learning algorithms. And regression, if you want to estimate, if you want to predict, what will be the stock price, what will be the price of the house in your area, in your region. So you can use information such as what are all the house prices in that area in the different years, and then you can use that information. You try to use that data which is available to you. You try to fit a line or a polynomial, etc., and then you try to predict it. In data clustering, you're separating the different data, unsupervised or unlabeled data into different groups. I've shown you a two-dimensional picture there to separate out the different data into clusters. And then I have a data classifier which will classify your data. If it's called a binary classifier, if it is a class 0, if it's a class 1, and so on. Okay, so what is the basic underlying phenomena? And these days there is a lot of strength or lots of impetus on neural networks, right? Whether it's artificial neural network or whether it's convolution neural network, it's all taken from the biological neurons, if you say. So the human brain is made up of lots of neurons which are all interconnected with each other. It's a 3D muscular lump, and then there is a central nucleus, and then all the information goes through what is known as axon to the synapses. So we try to mimic the same neuron and same interconnection between the different neurons in the brain by making use of the digital replica of that neuron, right? So we have that axon or axon, and then the strength of the signal is measured in terms of the W's, the weights of the synapses, and then we sum all of them. You can see that summation symbol there inside the neuron. So neuron is a digital equivalent of that neuron, and then what exactly happened in the biological neuron is it inhibits the data, or it enables the neuron to participate in the propagation of the information, right? So that is tried to emulation through what is known as bias, that B term there. And also these neurons, which are all interconnected, can do lots of complicated things because of there is a nonlinearity there, which is a function. So that nonlinearity is usually a sigmoid activation function, as you can see there. Or there are other simpler nonlinear functions such as rectified linear unit and so on. So this nonlinear function acts upon all the concatenated inputs to the neuron, which are all weighed, and then you added a bias, and then you submit it to a nonlinear function. So what is the deep learning approach? Deep learning approach is you try to infer the system. Nothing is specified beforehand other than how many layers you will use, how many neurons you will use, how many interconnections you will use. So everything else, the weights of the branches which connect the neurons to each other, all that is learned from the data itself. So it is a data-driven model. Till the advent of machine learning or advent of artificial neural network, we used to say what is the weights of that, what is the system, or we used to represent the system in terms of equations, but now it is all learned from the data. So therefore, you need to have large amount of data. It's not just a fewer number of data, then it will not suffice. So you have to have large number of data, and then you derive the system from the data itself. So it's a data-driven model. So some of the applications which have paved the way for growth of artificial intelligence and also machine learning is the algorithms which are used in neural networks. And one of the algorithms which is very widely used in neural networks is backpropagation algorithm. So people knew if there is an error at the output, how do you use that error to train the neural network of the layer before that? But how do you propagate that error to all the previous layers people never knew, did not know about that. So therefore, backpropagation played a very crucial role in, you know, in giving a big impetus to the neural network. And also the data, people also were having a large amount of data like pictures. These days you take innumerable number of pictures through your mobile phone, and different types of pictures are also there. So large, humongous amount of data is there. Algorithms such as backpropagation is there. And also all this backpropagation algorithm can be put in the form of a matrix multiplication. So matrix multiplication is a structured computational element, so which you can use you can use special processors which can do this kind of a matrix multiplication time and again very fast, such as GPUs. So these are the three things which have given this greatest growth in machine learning. And also there is a training phase where you will train the neural network as to, to understand, to associate with the data which you have given at the input, and then at the output, the neurons will tell whether the input is a dog or a cat or etc. I have shown you a picture. It's an object classification picture. And then after millions of pictures are shown, it will learn, and then you deploy that neural network. These days one can deploy that neural network on mobile phone also, on your laptop also, and these days one can also do this deep learning by making use of some of the models which are there in the internet. Companies like Hugging Face gives lots of neural networks, and also you can train your own neural network to learn the languages of your choice, like Tulu or Kannada, Indic languages, etc. Right? So that's all possible from Meta Llama paradigm. So basically what this deep neural network does is it tries to characterize the input, which is it tries to learn the different characteristics or features by which it can define or it can explain the input to the neural network. Okay. So here you can see the basic primitives, which are all lines, and then horizontal lines and vertical lines and diagonal lines. And then when you come to the next layer, all these lines are interconnected with each other, and then they give you a mid-level feature as to curves, and then the noses, etc. And then this is a slide of picked up from NVIDIA's slide, which is face detection. I think the first person was talking about face detection. So, and then the later layers of the neural network will collate all these primitives and give you higher definition of the image that is being recognized or classified. So so all we are talking about is digital neural network, right? So one has to digitize your input, whether it's voice, whether it's text, it has to be digitized. So if it is a grayscale image, I saw many presentations today where they were taking pictures and then they were doing the deep learning or machine learning. So you convert this data into a digital data. You take the picture and then digitally they are just nothing but numbers. They could be 8-bit numbers or 10-bit numbers. And if it is a color information, then it is a 3 attributes of the colors, R, G, B components, and these are also numbers. So neural networks are very good at crunching these numbers, and it's, as we will see later, they are all nothing but matrix multiplications, and then they will learn from the patterns which are there in these data. Okay. So the deep tech is, as I said, some of the algorithms which have given a big impetus to the deep tech. Deep tech is the new name for deep learning, and it's the backpropagation. And compute, as I said, the GPUs are there, and today one can do the computation not on your computer because it's billions of parameters, and then multiplication and training may take a lot of time. So people use cloud technologies such as AWS, that is Amazon Web Services, and data. So if you have limited data, let's say that you are trying to do a machine learning on a limited data, so you can expand your data there are many techniques such as augmentation of the data, right? And also you need to balance the data so that the different classes of the data have to be equal in number. So balancing of the data, augmenting of the data is all possible if you do not have enough number of data, because machine learning is a data-driven platform, and then it needs large amount of data. And performance, how do you measure the performance of the various machine learning algorithms? So there are metrics such as if it is a medical machine learning technique, then there is a false positive and false negative, recall and precision and F1 score, etc. These are all some of the metrics. And also there is a loss, that loss which we saw in the previous object recognition, where it doesn't predict the class the neural network is tuned to be. Then you use that loss to propagate it backwards as an error, and then you try to find out the updates to the weights of the neural network. So this is the performance. And the theme of this conference is responsible AI. And how do you create trust? Because this is all, as I showed you in the previous slides, these are all nothing but a large number of compute elements. You don't know what's happening underneath. You don't know what is happening under the hood. And it's a black box, right? So nobody can explain it. So how do you explain that? So that people will trust what is being done through the machine learning techniques. And there are privacy of data needs to be confirmed, and then security of the data needs to be confirmed. As today's first speaker was mentioning, it's biased towards white people, and then not take the information from Hispanics and then blacks and etc. So such kind of, because if you show the machine learning technique more of the data of one particular ethnic group, then it will learn the characteristic or the feature of that only. And when you give it Asian population or Hispanic population, naturally it will falter. And there were lots of lawsuits in London and elsewhere where the faces of other non-Caucasian people were taken as criminals, right? Okay, so I will just come to the widely used and widely talked and widely used by the students also of the transformer architecture called ChatGPT. It's a generative pre-trained transformer architecture. This is a newest technique of ML, and it has come into vogue after the 2017 paper by Google, which said attention is all that you need in order to learn about deep learning, in order to learn about the feature. So basically there is a input embedding. So it's basically ChatGPT you must have already used, and then it tries to give you the next word and use that word to, and it gets trained on a humongous amount of data which is there on the web, which is there on the books and so on. Text data it learns, and then it also, this is also nothing but a large number of neurons and large number of computations, and all these computations can be put in the form of matrix multiplication, right? I have a next slide wherein it will show you how does this billions of parameters of a ChatGPT come through, right? And also what are all the different computations that are required. And I don't have the slide for that, but the input to that is text, and then you will have to say where the words are all embedded in terms of some compute vectors, and then where that word comes in the big passage, right? So therefore you have a positional encoding, and usually the positional encoding is sinusoidal encoding. And then there is a multi-head attention. Attention is, as the title of the 2017 papers, attention is all you need. So this is one of the main component of ChatGPT, what is called a large language model, where it will try to infer the words and the effect of the neighboring words onto that. It's something like a natural language processing, where a word is not independent by itself, but it gets influenced by all the passage and that is what happens in attention component of this neural network. And it depends on the context. If the large language model can hold a number of data, and GPT-3, it is incidentally 2048 words it can hold at any one time, and it can find out what is the relationship between the different words and how do the different words influence each other. So that is estimated in terms of what is called attention blocks, and then multiple number of attention blocks are there in the ChatGPT, and 96 such blocks are there in GPT-3. And it also uses artificial neural network, which is a feed-forward neural network, and that gives 2/3 of the billions of computations which ChatGPT does, and 1/3 of the computations are coming from the multi-head attention, which is also very well. It can be put in the form of matrix multiplications, and then it tries to learn what are all the context in which the words are being used in the story or in the essay, article, and so on. And then it tries to find out the next word based on the influence of the previous words in the story, and then it uses that in the ChatGPT or summarization of the various documents such as PDF. You may have used on the internet online sources, where if you just give a PDF, instead of reading a big paper of about 10 pages, you can ask it to cut short and minimize and give you the gist or the summary in just about half a page or something like that. So all that is possible because of text learning by this ChatGPT. And also it can do multiple languages translation also, from English to Kannada and from English to Tulu and so on. So all that other language in which you want to do the translation needs to be given as through the output, and it tries to predict the next word and uses that word in order to recompute the state of the system. That is the transformer architecture. Well, this uses about 173 billion parameters. That is the number of computations that goes through a ChatGPT. So therefore, it needs lots of power. So whenever you give a question to the ChatGPT, naturally it has gone through all these computations in order to arrive at that. And these are all the 8 different categories in which the matrices can be split into. There is an embedding, that is the embedding of each word in terms of a vector. So there is an embedding, and then there is key, query, and value, which is used in attention. What are all the influences of the different words in the paraphrase or in the paragraph or in the story on different words. And then up projection and down projection is nothing but some kind of a simple neural network. And you will have to see, all these neural networks work on numbers, right? You will have to take back the numbers back into your word space, dictionary space. So that is unembedding. So putting all together takes about GPT-3, the former version of GPT, takes about 175 billion computations. Okay, so this is known as a large language model. So there is embedding. So embedding is the words are all converted into what is known as tokens, and tokens pass through these are like how I showed you the pixels of the images are all concatenated to form a vector. So these are all the word embeddings, and they are known as tokens. And attention is very important here, because the influence of the context, one word on another, that the context and the syntax and then the influence is all estimated there. And then there are large number of multi-layer perceptrons also. Apart from embedding, apart from attention blocks, there is MLP blocks also, which will hold the different influences among the words, and also which will give you greater meaning of syntax and then semantics and so on. So it can learn so many things. So these days the attempt is to increase the number of context data so that it can, put in a large number of dictionary, and then it can learn from that. And these are all nothing but matrix computations, and which are all very useful to put if you want to accelerate them using GPUs. And there is a reinforcement learning in order to get a human-like touch, human-like output of this GPT. So a large number of trainers were used in order to arrive at reinforced learning, and so that it can be presented in a nice format. It's not uneven text and uneven length sentence and so on. Okay, so I was talking to you about a large language model is trained on web pages and then articles, etc. But if you want it to focus on a PDF file and summarize it, then you will use what is called a retrieval augmented generation, which is an addition to the later form of LLM. So there is an LLM, as you can see here, but it will not, LLM is just, general type of text generation, etc. But you have taken a PDF and you have given that PDF as the input. So it will take chunks of the PDF, it will take some of the key words from the PDF, and then it will combine with the query which you have given to the large language model. It will combine that so that the large language model focuses on your PDF format, PDF information. So if you want to know about your calendar, or if you want to know about your insurance policies, etc., so you can train it to, you can ask it to, you can give the information about your policy statement, or you can information about your calendar, and it will learn, and it will give you an LLM specifically meant for only your personal details. And these days there is a AI agent is going to be a next set of things which are going to come in vogue, and these are also kind of LLMs, but not LLMs exactly. They will do specific tasks, right? So AI assistants will come into vogue, and and they will, for example, I want to write an email to Professor Khan. So it will not only do the finding out whether Khan sir is free or not based on his calendar, but it will also make a call to him and see whether he is available or not. And then there is an embodiment also, there is a robotic system also, so it will combine the task. It's specifically meant for only tasks computation and for your task computation, and it will use the LLM. Okay, this is the NVIDIA GPU, graphical processor unit. As compared to a CPU, it will have many ALUs, arithmetic logic units, and most of its semiconductor infrastructure is used for that. Well, this is an old version of NVIDIA GPU, but these days it's A10 and H10. And it has got a large number of what is called as stream processors. And these stream processors can be coded to do lots of computation, arithmetic. If you can simplify your computation, like matrix multiplication or matrix addition, you can simplify into different components of that, and you can ask each one of these stream processors to implement that computation. Well, this is an example of a very earlier version of CUDA program, which runs on the GPU, I have shown here. And this is what one uses if you want to, as I said, I basically work on implementation of the AI systems on the hardware. So this is a NVIDIA Jetson EVK. If you want to use it for face recognition, object recognition, etc., one can use this evaluation kit, which is from the NVIDIA, and it's called Jetson. You can connect a camera to that. You can connect different peripherals to that. And Raspberry Pi is very well known among, especially from the students' point of view. And there are a big number of opportunities in AI and ML, thanks to 5G, and also cloud computing and semiconductors, as I said. And it will throw open a large number of opportunities for people to, local entrepreneurs, to have their own businesses and setups, etc. So how to start a career in data science and machine learning? Well, this is about data science. One has to learn statistics. One has to know about Python programming because it has got large number of libraries. And there is a coding platform called Jupyter, or you can run a Jupyter from your web browser, such as Google Colab and so on. Participate in hackathon. And Kaggle is another very good resource where you can find data and algorithms, etc. of these machine learning algorithms. And these are some of the libraries. NumPy and Pandas is in the Python. TensorFlow is to represent machine learning. PyTorch is another significant library one can use in order to specify what are all the machine learning parameters and how do you train them and then how do you test them, validate them, and so on. Well, this is something in which we worked a long time back. How do you curate the data and then how do you train the data, train the machine learning model and then run it on the GPU. Well, you can visualize the various weights in terms of pictures also. That is what this says. This is also given by NVIDIA. And these days, if you want to come out with a new killer application, one needn't, there are people, vendors who give you lots of businesses. And all you need to do is just collate all of them and then give a killer application or a killer job. And for example, Netflix is one such operation. They don't produce anything. They don't produce any videos. It's all OTT, etc., which we all know. So the content is all taken from TV shows and movies. And there is a stack, which is also specified in terms of the AWS. And then the distribution, the streaming, etc., happens on Akamai and so on. There are these streaming platforms. And playback also often, happens on your laptops and then your mobile phones and then your TVs, etc. So none of them is owned by Netflix, but it collates all of them and then it makes $1 billion business. Okay, so these are some of the applications and future. Well, 2025 sees a plateau of deep tech. People are kind of, we were all mesmerized by deep tech, but people have now reached a plateau that it cannot do much more things as was thought of or anticipated. And it needs huge amount of computational power because large number of data centers are being used, especially for large language models. And agents and assistants, digital assistants are going to come in a big way to help out our daily life. And jobs, especially among the students, this was also told in the first presentation today. Jobs may go, but one has to keep himself or herself trained. And you have to embrace, like how you're using ChatGPT, you'll have to learn how this exactly works, ChatGPT works, etc. One has to know, and you have to build and deploy and then train, etc. One, if you know and embrace it, I think your life will be good. Okay, thank you. That's all I have.
Friends, respected audience, could you have any sort of
questions?
I'm 85 years old and this internet and all are new things to me.
Okay.
So it's an education for me to listen to you.
Thank you, sir.
Why is it called machine learning? My question.
Okay. So it's a learning. So how do we learn from our parents? How do we learn from teachers? They hold a stick or, they make us learn. But here it is the machine which learns, right? It's not analog information, it's not voice, or it's not, pardhanas, or it's not different language constructs like Tulu, etc., where our parents and our teacher tells us. It's all digital representation which are translated into machines, and machines learn. The knowledge is created by the machines, and then they take up some decisions as to what needs to be done, etc. That's why machine learning. Yeah.
Thank you. And now we are using this deep learning.
Yes.
For all these millions or thousands of years, people were only learning. Now we have gotten to the stage of deep learning.
Yeah, deep learning is you have to learn from the data itself. You don't have any equations or systems, etc., which will mimic the learning system. You try to learn the system and the equations governing that your machine learning system from the data itself. So therefore, it's called deep learning, deep tech. Yeah.
Any of the other, please?
Yeah. Thank you.
For the very informative presentation. Obviously, it is the fact that it is fascinating what AI and ML is doing at the moment. So just out of curiosity, what do you think the future holds for AI and ML, especially if, like, probably in a couple of years' time, if they come up with quantum computers?
Yeah, the thing is, well, I forgot to tell you that. Actually, this computation is very enormous now, humongous right now, and also it consumes lots of power. Data centers needs a lot of power, etc. Right? But it is been tried, or research is in that direction, where all these matrix computations are all, matrices are all sparse. So you needn't do all that computation. You needn't do all that multiplication. So people are trying to build systems which will use this sparse characteristic of these matrices and then reduce the amount of computing. As you rightly said, quantum computing is another thing which will do very fast computation, etc. And it has got multiple stages and multiple levels, etc. So that's going to definitely speed up the AI, right? But what AI will take us, whether we will have general inference, etc., which like human beings do and take decisions, etc. We have not reached that particular stage yet, but maybe in the future, maybe that's what Eric Schmidt of former CEO of Google also says, and he is afraid, and George Hinton is also afraid that it will become very powerful, and then it will, and also your Yuval Harari is also very afraid, the historian from Israel, are all very afraid that machine learning will take over human beings, human Homo sapiens, and then it will control us. Yes, that's the problem.
Because you did mention when you talk about the future, the power consumption, because obviously quantum computers are losing a lot of power,
Right.
so environment pollution as well indirectly, isn't it? Yeah.
Sure.
Perfect. Thank you so much.
Thank you. Exactly.
Every word will have comparison with 248 words.
Correct.
And they mentioned some 17 billion.
Yeah, because it needs so many computations. Attention is only 1/3 of the 17 billion computation. But there are also multi-layer perceptrons which will hold and store all this data. So that also needs to be trained. That will hold 2/3 of the data. 2/3 of the parameters.
That perceptron exists there, or it's a comparison phenomenon that goes on?
It goes on. It goes on. So therefore, whenever you give a query to the chat GPT, it has gone through all the 175 billion parameters and it has computed. It has given you that result. So therefore, probably in some data center in China or Chennai, you have used all that power consumption. Right now, Google doesn't charge you that. OpenAI doesn't charge you that. But I think their higher end of Chat GPT, Chat 4o, etc., they charge. Yeah. How many queries you give, based on that you're charged. Yeah.
Even for preset writing, it does all that job of comparison. Even if it is preset writing, like reducing.
Exactly.
Reducing a bigger para into a small one.
Definitely.
The same thing.
Definitely.
Thank you, sir.
You mentioned about Harari. He's an interesting author.
Yes.
He's written 3 books, and the first one is Homo sapiens.
Exactly.
It's about human evolution.
Right.
The second one is Homo Deus, something to do with God. And the third one is 21 Lessons for the 21st Century.
Exactly.
All the 3 books are very absorbing.
Right.
Now the latest book of his is called Nexus. I don't know, I've ordered for the book. It will be coming in the next couple of days.
Okay.
So just to tell the people here
Sure.
about Harari, very interesting man.
Correct.
Thank you.
Yeah.
See, now everybody uses AI almost rigorously and very frequently. So, whether the output can be protected in the context of like intellectual property rights, if yes, then who would be its primary owner? Whether the prompter, I mean the user, or the developer, or this is also a collaborative effort. Like it is developed using data sets and all. So, who would be its primary, I mean, owner?
See, one thing is it's a revolutionary idea, and it will give you a lot of ESOPs, right? And you will suddenly become billionaire, and you'll suddenly become rich. And that's why there was this big quarrel in OpenAI. You know that last year or this year there was a big quarrel among the various stakeholders in OpenAI. So that's one thing. And deep tech is not controlled as of now. In spite of all, different governments are talking about that, it's not controlled as such. So therefore, there are these pitfalls of taking this deep tech to higher levels, and somebody has to come out with regulations, and people like George Hinton and Eric Schmidt, they're already talking about, some kind of a regulator needs to be there. And all these companies like OpenAI, Microsoft, and Google, they can flow money like anything. They have dollar bills like anything, and compute power is at their hand, right? So they can do all this kind of thing. And a small startup like me, sitting in a corner of Manipal, we cannot do all this. So that's the problem, yeah. Sure. Correct. True, maybe the ownership lies with OpenAI because it has, brought up that system, that LLM. It's true, and also somebody has written all that. See, it has all imbibed all that information from the web. So somebody has written some web page, web article, etc., which is all sitting in different parts of the world, and it collates all of that. So who is the staker and who will take the responsibility is a big problem. As long as you are creative, that's why I ask my students to write first by themselves, and then if they want, take some clue or cue from the ChatGPT, and then make a comparison, and then you can improve upon the essays and the assignments you do. Okay. Okay. Mm-hmm. Okay. Correct. Okay.
There it was about regulations for regulatory things for AI.
Sure.
ISO and IEC. Yesterday we had a talk.
India also has that IT Act of 2000. Privacy and
To all expected, see, generally what will happen today, like you are seeing the buzzwords which are going from the technological aspect, like you are reaching the AA with the help of ANN, CNN, wherever it may, whatever it may be. You are finding with respect to the research innovation exponentially finding. But other end also, in a printed media, what we are observing, like people are going to lose the job opportunities. The employment opportunity, what is your view on this one? Just because we are observing, like whatever the MNC they used to be say, correct, no, approaches are very clear, use with the help of the standard AI or the ML or deep learning, whatever it may be. But you are finding those who are skill level oriented employment, which are going such a way that, which are below level of the, how the employment. That is also the big question at present in front of us.
yeah,
Could
lots
you?
of jobs will be going, and especially we have seen about 3 decades ago, computers came into our banks and offices, etc. And unless people got trained in all those things, they kept their jobs. But otherwise, many people lost who couldn't, comply with that. For example, in the UK, there is a magazine called Guardian, which used to come in the print media, but it's no more there. So many such things have happened. Yeah. Thank you. Thank you very much.
I hope no more questions. Thank you very much, Professor Niranjan. You please started with like a 5 icons with respect to the physics and chemistry, then followed by the pitch, correct? No, the idea which are the CEO of the Google, and given a very clear picture about the buzzwords of, because the computer is a commonly usable and the optimal and materialistic and the universal and performance and askable one. But today you are standing like a globally digital paradigm. Like without zeros and ones or nothing is going to be worked out. But you have to use a different type of an algorithms or making models or the techniques which are highly oriented, probably. Thank you very much for your exertive and very provoking thoughts of the AI application. And thank you one and all on behalf. Just I request Professor Kanji. Yeah, please. Thank you. Thank you very much, sir. Thanks a lot.
Good afternoon, everyone. On behalf of staff, student, and the management of Mangalore University, I would like to extend our heartfelt gratitude to Professor Niranjan UC for an insightful and engaging session. Your valuable insights have truly enriched our understanding of the topic. Now I request the convener of the program, Professor A.M. Khan, to present a memento. Professor Manjay sir to present a memento to the speaker. And I also request Professor A.M. Khan as well as the co-convener of the program, B.H. Shekhar sir, to present a memento to Manjay sir. Thank you, sir.
Good afternoon, one and all. Here we will start the next set of paper presentation session. I welcome all the paper presentators online and offline who've come here. And we today have roughly 6 papers that are being presented in this session. The paper IDs are as follows: 048, 053, 055, 059, 070, and 072. I request all the presenters to be ready with their presentation slides and directly go to the presentation mode once the screen is asked to be shared and once your time starts. Every presenter will be given 8 minutes for the presentation and 2 minutes for the Q&A. Please adhere to these timings. I welcome Dr. Prahas Amin, Head of Computer Science and Design Department of Canberra Engineering College, as the chair of the presentation session, joining us offline here. Also extending a warm welcome to Dr. Murugan, joining us online as the co-chair of the session. Thank you for joining us, sir. Now I request presenter with paper ID 048 to start with the presentation.
Am I audible?
Yes, you are audible.
Whether the screen is visible?
Cool. Noted. Please share your screen.
Yes, sir, you are audible. But your screen is not visible, sir.
And now?
Yes. Please move on to the
Yes, you can put it on slideshow mode, sir.
Yeah, good afternoon to all. Myself, Anand Krishna Kamath. My paper title, Hybrid Machine Learning Regressor for Effective Short-Term Load Forecasting of Talapadi substation, and these are my co-authors. This is the introduction. Electric load forecasting is a process of predicting how much electricity will be needed at any given time, and how it will affect the utility. As we know from the diagram, the electricity is generated from the generating units, and it will reach the consumers via transmission as well as the distribution lines. So here the consumers are different types, like a residential consumer, commercial, or industrial, and these are the transmission lines. Now mainly focus on in our paper prediction how much load is required for this substation, which is consisting of all the kind of the consumers, residential, commercial, as well as the industrial. And this is the motivation, because everyone knows that the electricity is the main source of energy nowadays, because from the lighting to the heating as well as the motor driving, everything, electricity is required. And the consumption of the electricity is varies depending on a time, depending on a region, as well as the depending on the type of the load in the particular region. So these are some of the related works, and if I focus on these related works, they have machine learning models only they have designed for the prediction purpose, but the data they have used or consider the type of load is specific, either a residential consumer or a partner institution level data. Here also the university data and all those things, and here the machine learning concept they have used are simple machine learning regressors like support vector random forest, or somewhere here it is a SVR, and so on. So in our model, we have our work is divided into 4 phases: data collection and segregation, then pre-processing, then model selection, and model evaluation. So in our work, we have collected the data from Talapadi substation. This is the Talapadi substation data, which consists of room temperature, weather, frequency, and different feeders which are connected to it. We have selected only the station peak, ignoring all the feeder load. Some of the each and every feeder station peak is considered in our data. And after segregation, this is the kind of the information what we will get, with the date, month, time, and the temperature during the recording, and the weather condition at the time of recording, and the frequency at which the load is dispatched, and power consumption in megawatts. So here we can see that the load weather parameters is categorical in nature, something like a clear, cloudy, and rainy seasons, and some of the data were having outliers. So those things we have analyzed from the box plot. From the box plot, we can get that the temperature is having outliers, even the frequency is having outliers with the value of 0 also, even in the load, the outliers with the 0 recording. That means this 0 recording may be because of the power grid is not received any power due to some failure in the transmission line or the distribution line. So in such 0 recording or missing values are to be handled carefully before applying to machine learning concept. So to handle this, there are the 4 different types we have handled. Handling the missing values, in which 0 recordings are to be modified. Here there are many methods, but still we have used the KNN imputer. The reason for KNN imputer is the load at a particular instance, it depends on a particular day, because the load consumption is the rainy season, and load consumption in the winter season as well as the summer season is entirely different because of the temperature, climate conditions. So for that purpose, keeping that in mind, the 0 recording at any instance is replaced with the KNN imputer, which replaces the mean of the 24 nearest neighbor values, where considered K as considered as 24. So by keeping that one day in a mind. Then handling the outlier values, for this we have used a cap or a floor method. That means in the outlier is above the 1.5 of the Q3 interquartile, 1.5 times interquartile range above Q3, then it is replaced with the cap, and if it is below the 1.5 times of the interquartile range of Q1 with respect to Q1, replace it with the floor. Then as we have seen in the data, weather data was a categorical, so that is to be replaced. So here we have used label encoding for replacement, which will convert a categorical data into a numerical data. And the scaling is a min-max scaler is used mainly in the frequency and the load. There is a huge variation and in the data, and mean is a very high. So in that case, we are replacing with a min-max scaler in our project. And model selection, particularly our data, we have considered ensemble stacking regressor. In this, what happens, actually the data is split into training and tested data. And in the training data, based on the number of base model considered, the entire training data set will be divided into k fold, out of which 3 will be trained by one of the base model. Here it is the ridge regressor, and then the remaining last fold will be tested for a particular base model. Similarly, it will transit for the other thing. So here in this particular case, we have considered the base model as a ridge regressor, decision tree, random forest, and a gradient boosting, and meta learner, which will take the combined effect of all this ridge regressor, decision tree, random forest, and gradient boosting, and it will predict based on the result of this, which is considered as a meta learner. And using the meta learner, it will predict the final prediction. Then the model performance is evaluated using these 4 parameters: mean absolute error, mean bias error, root mean square error, and R2 score. Now, this is the result what we got when we are individually trained with the simple regressor. This is by using a multiple linear regressor. Result between the actual blue color and orange color one is the predicted value, and this is the using a ridge regressor, and this is the difference between actual and predicted using a decision tree regressor. This is with RFR, random forest regressor, and this is the gradient boosting, and this is our model stacking regressor output, difference between the actual and the predicted value. But from these waveforms, we cannot measure the how efficient it is. So for that purpose, we have calculated the evaluation metrics, MBE, RMSE, R2 score, and this one. And in this, our stacking regressor bias error is minus 0.002, which is very, very low. And root mean square error is 2.08, which is also low compared to others. And R2 score, which is high, 83.8%, 0.838, and mean absolute error is 1.37. On comparison with the other simple regressor, the stacking regressor shows the better result. Now in the evaluation matrix root mean square, it stands in line with the random forest. Even in R2 score, it is in line with the random forest. Here mean absolute error. But in terms of the mean bias error, the stacking regressor exhibits a very good result, very low, 0.002 compared to the random forest error of 0.05. So from the overall this, we can infer that stacking regressor shows the better result for a short-term load forecasting of a Talapadi substation data set. And it can be implemented for medium and long-term load forecasting also. But only the thing is, data set we have to consider the not hourly data set. It is the daily load consumption data. Based on that, we can predict for medium term as well as the long term load forecasting. Thank you.
Thank you, sir. That was a good presentation. So could you just elaborate a bit about the data set that you have used. So, like, what was the period? What was the
Thanks for
duration
your
for which you
presentation.
have collected the data?
The floor is open to the audience. Any queries from the audience side, in online or offline?
Yeah, sir. Sir, go ahead, Murugan sir. You can go ahead with your question.
Okay. So if no queries from the audience side, I have a doubt on your presentation. You said it's a hybrid machine learning regression model. Yes, the application is fine. From the Talabadi substation, you have collected the data set, and your objective is to find a short-term load forecasting. Why do you prefer a hybrid model? Why come it is not efficient on the individual models? Why do you go for stacking? What is the reason?
No, initially, we are, as I am from my electrical background, I am least aware of this machine learning concept. So initially, I searched with a simple regressor model, and when I tried with those things, I got a accuracy of a 0.37, 0.38, and so on in the initial phase. So later, I thought that this simple regressor model may be less accurate, or some kind of the modification is expected. So for that purpose, I went to the hybrid model.
And either also you try to combine more than one models, right? So have you tested with the various combinations, or
We have tried with the few, not all. In that we have trained with 5 different combinations. In that, this one found is a good. This exhibited good result compared to other.
Great. So, but since the research is related with the machine learning stuff, even though I can understand your background, in your research paper, we need to justify why we choose hybrid model. So, if you have the results with the individual models, you can compare and justify why do you move on to the hybrid. And in hybrid also, what combinations you considered and tested and why. So, this must be justified in the results and discussion. So, which will be helpful for the new researchers or even any other researchers with your next generation will be helpful for them to proceed.
Okay.
So that's it from my side. Any other queries?
So could you elaborate on the data set? Like what was the period that you have used? What is the period that you have recorded the data?
Shall we move on to the next paper?
Yes, sir. The next paper is ours. I'm going to share my screen now.
I think the paper ID 53.
Yes, sir.
So I invite the presenter, Bhavani ST. The paper title is Feature Descriptor and Selection Techniques Analysis for Signature Verification using Recommender System from JSS Science and Technology University, Mysore. So you can start your presentation.
Is my screen visible, sir?
Yes, your screen is visible and your audio is clear. Please proceed.
Okay. Good afternoon, one and all. This is Dr. Bharti RK presenting my paper, Features, Descriptor and Selection Techniques Analysis for Signature Verification using Recommender System. The main idea of going with this work and this paper is to come out with a recommender system for offline signature verification system where enormous number of feature extraction selections techniques have been used in the for the last 2-3 decades. However, we made an attempt over here to come out with an efficient way of coming out with the recommender system where we try to explore a comprehensive set of features for offline signature verification, beginning with the feature extraction using descriptors like histogram of oriented gradients, gray level co-occurrence matrices, local binary patterns to capture the distinct texture and structural properties of the signature, followed by the various feature selection techniques such as Fisher scores, genetic algorithms and mutual information, and apply to isolate these onto the various classifiers like support vector machine, random forest and k nearest neighbor to evaluate these efficiencies we have used three major data set, publicly available data sets such as CIDAR, MCYT, and BHSIG 260. The major motivation here is to extract the intrinsic features playing a significant role, okay, and coming out with a larger set of features. Always we face the curse of dimensionality, high computational complexity, and retroid the verification, which retroids the verification results. So as I already said that good work of related works have been identified, tabulated over here, where we can see all these authors have come out with various combinations of feature selection and feature extraction techniques with different classifiers resulting in different accuracy results. However, an attempt was made to come out with a recommender system combining three major feature selection technique and three major feature selection techniques and three major classifiers on three major data sets. The overall observations and the proposal focused here is to come out with the advantages of traditional machine learning over the deep learning. The point here I like to bring out over here is, as we all know that the deep learning mechanism, deep architectures are giving an extensive results, however demanding a larger data set and higher computational complexity. So here we recommend the optimal combination of features extraction, selection, classifier with the goal to leverage the strengths of the traditional approaches with lower data requirements, interpretability, and faster training with better handling of small data sets. And we also focused on developing a robust and efficient signature verification system, seeking to provide a solution that balances the accuracy, speed, and resource efficiency. However, maintaining the transparency needed for the real world applications, that is in the terms of the complexity, time complexity, computational complexity, and accuracy. The proposed methodology goes like this. We have the data set. Relevant amount of pre-processing was done in order to incorporate the size and maintain the uniformity over there. The feature selection techniques used, as I already said, is the HOG, GLCM, and LBP. Feature selection techniques used over here is the mutual information, genetic algorithm, and Fisher scores filter approach, and with three different classifiers: SVM, random forest, and KNN. We have come out with the extensive good number of models with these combinations, and of course a recommender system which could recommend which best combination would yield the higher accuracy results. So with larger amount of computation on the three data sets such as the CIDAR, BHSIG, and MCYT, as we see, we have considered three different languages also over here. CIDAR focusing on Latin, BH6 focusing on Bengali, and MCYT focusing on the Western data set with forged and genuine samples also. Yeah, as I said, a smaller amount of pre-processing was done just for the reshaping and reforming the dataset into uniform size. The feature selection technique, the histogram of oriented gradient, helped to give out the data, the features at the pixel level with various gradients and orientations. So this is how we extracted the HOG descriptor, and this is how the feature selection, feature selected size is. I'm going to tell you like how best the feature selection helped us to reduce these features size that has been extracted over here. Similarly, the GLCM gray level co-occurrence matrix with various directions yielded as different features such as the contrast, dissimilarity, homogeneity, energy, and correlation. And each of these feature extraction techniques have their own unique strengths and limitations, yielding a better method for feature extraction technique. The third one used was the local binary pattern, which captures the local features of an image, comparing these each pixel value with the surrounding neighborhood. So these three descriptors helped us to come out with a very good number of features. However, these feature selection techniques such as the mutual information, Fisher scores, and genetic algorithm also helps us to how best that we can reduce the feature size and select the best features out of this. As I already said, like mutual information, Fisher scores, or genetic algorithm, each of them have their own strengths in helping us to come out with a very appropriate and optimized way of selecting the features. This is how the feature selection techniques works, and these three classifiers, SVM, random forest, and KNN, were used to work on the classification of these G9 signature versus the 4 signature. Okay, and however, finding out with the accuracy of these models with appropriate FAR and FRR. So this is how the support vector machine works. The random forest, why random forest? Again, handles the nonlinear data effectively, reduces the overfitting compared to a single decision tree, and appropriate choosing of k value gives the KNN algorithm appropriate classification method. And as I said, this is how the final resultant reduction in the size of the feature helped us. They hogged with 324 features. The selection technique helped us to come out with 150 features with mutual information, and Fisher scores gives 150. Similarly, with GLCM with 20 features, these two helped us to come and reduce it to 10, and LBP with 80 features out of 170 features. The major factor is here is like, as I said, this is on real-time application. Henceforth, we are aiming to come out with a recommender system wherein the minimum number of features would help us for appropriate classification of giving the higher accuracy. So this is the 3 split ratios that we have worked upon with 60-40, 70-30, and 80-20 with the total number of images in 3 different data sets. Now moving on to the experimental results. These are the results obtained on the SIDA data set. However, the best results obtained here in these 3 combinations is HOG with GA and SVM yielded 94.48, GLCM with genetic algorithm with random forest yielded 100%, LBP, mutual information, and random forest yielded 96.12. Considering these best results itself, we can identify like how this recommender systems helping us like to choose the best combination instead of trying all the combinations. Similarly, results on various feature selection, extraction selection on PH6 data set. Even here, the HOG feature with genetic algorithm and KNN yielded 95.37. GLCM with genetic algorithm and random forest yielded 93.61, and LBP with GA yielded 89.61. The best results for MCYT dataset is with the genetic algorithm with HOG features and KNN 93.81, GLCM, Fisher scores, and genetic algorithm with 83.61. So this is the recommender system that we have built, where we have different extraction technique, selection technique, and classifier. And the recommender system helps us to choose automatically the combination of this for whichever the data set we employed upon. Yes, this is how it recommended, saying that for which data set, which is the best set of extraction, selection, and classifier works with. To conclude our work, the feature selection, extraction, and selection methods play a significant role in any of the machine learning problem. However, the same with respect to the offline signature verification also. Hence, an attempt is made to extract the reduced set of OC features by adjusting the cell size, and using the mutual information feature selection technique, the redundant and irrelevant features are eliminated, achieving the superior results on considered dataset for skilled forgeries, eliminating the non-performing features, enhancing the model's efficiency, and reducing the computational complexity. The future work focuses on finding the exact set of features required by exploring feature extraction and selection techniques. Yeah, these are some of the references. Thank you one and all. I'm open for the questions.
Yeah, thanks for your presentation.
Thank
The
you, sir.
forum is open for the audience. Any questions on both online and offline audience? I think in offline, the venue, the mic has been muted. Any questions from the audience side?
Hello, am I audible? Am I audible?
In that case, fine. Thanks for your good presentation related to this signature verification, because today in most of the application we upload our signature images. So
Yes,
there
sir.
is a possibility of reusability of doing any fraud attempts or forgery attempts into it. But in your overall presentation, you have used this ML DL techniques to mostly ML. With your ML techniques, you have tried to do the feature selection, and then you try to detect whether it is a genuine or forgery stuff. Where comes the you have written recommender systems in your title?
Yes, sir. Using all these combinations, we have come out with a recommender system where the recommender system goes with the combination of these three: feature extraction, selection, and classifier, and recommends for which data set, which is the suitable set of combination, it yields the best result. That is the major focus of our paper, sir.
Yeah, so in that actually recommend the actual recommendation system.
Pardon, sir?
Getting an echo from. Okay, so actually the term recommender system is something different, right? So here you are going to recommend your models, which model
Yes, sir.
suits for your effective detection of your signature or
Yes,
effective
sir.
verification of signature. So I
Yes,
think
sir.
that need to be customized in your title because the actual recommender system is something different.
Yes,
So,
yes. This is an initial attempt that we have made with three data set with three, feature extraction and three selection and three classifiers. However, the next attempt that what we are going is incorporating the AI-based algorithm where automatically it recommends it. Here, the recommendation is manual. The next we are going to do is AI-based recommender system.
yeah, I accept it, but I think you can coin the word in different way in your title, like recommending effective techniques.
Okay, okay.
Because the recommender system is something different.
Yes, yes, yes. Recommending effective techniques
effective
of
techniques.
extraction, selection, and
Yeah.
classification.
So you can customize your title in that way.
Correct, sir. Thank you. Thank you, sir.
Over to the organizer.
Am I audible now?
Yes, yes.
Yeah, ma'am, that is a good question. Yeah, that was a good
Question
presentation.
is not
ma'am.
audible, please.
Yeah, is it audible now?
Yes, sir. Yes, sir.
Yeah, that was a good paper, man. Good presentation. What was the drop in accuracy that you observed when the number of features were reduced? Was there a significant drop?
Yes, sir. In the accuracy?
Yes.
Okay. Accuracy, we got like, there's some repetition of voice. Okay, let me answer. So here
we are getting an echo. Dr. Ajaibat from Andhra University, I think we are getting an echo. Whatever we talk, we are hearing it back.
Okay. Can I answer now?
Yes, please.
Okay. Sir, there is no, more than saying the drop in the accuracy, it was, high in the accuracy with the reduced feature selection. What we did is like, whatever the features that we extracted, we applied onto the selection and classifier and we identified the accuracy. later reducing the features also when we applied, and we found that the same accuracy could have been obtained by the reduced set of features with the appropriate selection. Then we combined it and tabulated over here. So our point here is to say that even with the reduced set of features extracted, the higher accuracy could also been obtained. So this will help us like how the computational complexity can be reduced. Did I answer your question, sir?
Yes, ma'am.
Okay, thank you, sir. Thank you.
Any other questions? Okay, in that case, I think we can move on to the next presenter.
Okay. Yes. Thank you for the organizers for giving this opportunity. Thank you one and all.
Next presentation is with the paper ID 55. The presenter Priyadarshini R. For the paper Towards Data-Driven Insights on Sleep Disorders, Evaluating the Impact of Diverse Influential Factors from Cardiff Metropolitan University, UK.
Yes, sir. Thank you very much. Yeah, yes, sir. I hope you can see my screen now.
Yes, your screen is visible. Please make it as full screen and you can start.
Yes. Hello everyone, my name is Varprasad. It's my pleasure to present my work here. And my paper is regarding towards the data-driven insights on the sleep disorders and evaluating its impact on the different influential factors. So without delay, let me go to the introduction. That is sleep disorder. So many of us sleep every day, but in the world where we live now, we are experiencing the sleep disorder, which is referred to as a very common problem for now. It is mainly due to the technological advancement and many the decrease in the quality of life in our day-to-day life. And we can see, especially in the UK also, even the 1 in 3 people are affecting with the sleep disorders. So mainly there are few 3 to 4 different types of the sleep disorders. The 4 prominent of them are the insomnia, hypersomnia, sleep apnea, and the reduced in the rapid eye movement sleep. If we go one by one, if we look at the insomnia, that is our sleep time is reduced. We are unable to fall asleep. This is one of the kind of the disorder. And the hypersomnia is we sleep more on the daytime. So this is also one of the problem. And the sleep apnea is even we can see some people with high snoring. It is mainly due to the airway is blocked on the neck part so that they will experience the snoring. Because of that snoring, the overall quality of the sleep is decreasing. So this is also considered as one of the sleep disorder. And the another one is the reduced rapid eye movement sleep, or we can call as the reduced REM sleep. So what is it important? The REM sleep means the eyes will move rapidly. Our body will be in high temperature at that stage of the sleep. And if it is decreases, our memory consolidation and everything, every effects which is related to the mentally and the brainly will decrease. So which will further result in our lacking of learning new things on the another day. So that is also one of the sleep disorder. So the physical and mental health conditions very affect the regions which is leading to the disorder in our sleep. So even in our contemporary world, we need definitely a solution for this problem because all of us spend 1/3 of the time in a day to the sleep. So unless and until we resolve this problem with a data-driven insight, like getting the actual data and what is the problem, so we can't resolve this issue which we are experiencing every day. So if we go to the related works, what we have done already, and they have identified that these health conditions, like the long-term health conditions of the diabetes or heart diseases and the stroke, and these are all related to the physical and the mental, the brain-related diseases like the stress and the anxiety, all of them are linked to the sleep disorders. So they have identified on a medical basis, like based on how the disease, like the effects of the diseases on a human person, they have just estimated that there might be an effect on the sleep. but there is no study done properly with the data analysis and getting the insights what actually with that data with the people with this disease. So that is one of the main gap we have identified. And we have also identified that the sleep hygiene, the sleep diseases, the sleep habits, like at what time they are sleeping, at what time they are waking up, are they regular in their sleep, and do they have, if they have any problems, and how their sleep cycle is it increasing or decreasing. So these are all the problems we have identified, and we need a solution based on this for the gender specific, especially like the how the males and the females are sleeping and what is their problem, and if they have any diseases, how can their sleep problem is, like how their overall sleep time, how much time they are awaking in the overall sleep. So these are all need to be answered. So that's why where we are going to focus now, like the how the people with the chronic diseases, and how the people who are walking less, how the people who are with the obese and everyone. So all the physical parameters and the mental parameters are we are considering in this research with the actual data set, so we can recommend it to the AI and healthcare mobile apps. So that is our overall intention. If we go to the proposed methodology, we can see that we have taken one data set which is considering all the data, like the gender and the place and everything, and the what is the disease they have and how much they are walking, what is their obesity status and everything. So we have taken that one. If you give me a second, I can share the data set also later. If you have any queries regarding the data set, I can share that later. And if we go to the research, so the first question we are going to answer is regarding the genders. So how this sleep disorder is affecting on the different genders. And the second one, we have taken the most prevalent chronic diseases, that is the most common diseases, 7 diseases, and how they are affecting them. And the finally, like if they are walking, and how their step count and the sleep patterns are related. So these are we are going to answer. We have taken one secondary data from the Mendeley data, that is publicly available data. So we have taken that, and we have done some analysis in the Power BI. So we have used the Power BI as our platform to do the transformation, the cleaning and the analysis and the visualization and everything. And we have come up with the visualizations so that we can get the insights using the different filters. So if we come to the results, we have some wonderfully exciting results, like that the males are sleeping overall better when compared to the females. As we can see here that the average sleep time, like the overall sleep time for the males is more, and they are awaking for less time. So their awake time is very less and they are sleeping more. So that is one of the key thing we have identified in our analysis. And especially if we come to the females, there are two sections, like the single and the widow. And we have identified that the widow females are sleeping very less. So the main reason we have identified it might be, like as the name itself suggests, that the widow, they are widow. So that the emotional state of a female lady is very influential on their sleep status. This is one of the key things we have identified. And if we go to the next section, that is like the BMI categories. So how the BMI category is affecting the sleep. So if you can see that the females with the higher BMI, like the overweight BMI, they're having almost 403, like the 403 minutes. So they are sleeping more. And if we can see, sorry, so this is 309, they're sleeping very less, like the females. So this is very like the mainly due to the hormonal change, as we have discussed, and even the BMI effect is also an additional effect to the overweight and the emotional state of a female. So we can identify that the females with the overweight BMI and their widow, they need to be very careful that they have very chance to get the sleep disorder of insomnia. On the other hand, the males with the higher BMI, they're sleeping more. So if they are overweight, does it means like they are always spending the less energy day to day. So they are spending the less energy with the overweight, and it is affecting their sleep. So this is also one of the key insight regarding the BMI effect on the sleep disorder. And one more thing, if we look at the 7 most common occurring diseases on elderly people, as because our research is focusing on the elderly people with the sleep disorder, we have seen taken the 7 diseases And we can see that the diseases, especially with the physical effect, like the diseases which can make the person less active physically, is affecting worstly, as we can see on the first three are the urinary tract infection disease and the osteoporosis with the fractures, if they have any fractures, and the arthritis. So these are all the diseases they are making the patient, whether they're male or female, they will make less active because of the disease. So we can see that the effect is very worse on that, and with the increased in the awake time. So if the awake time is more, it means like we need to, they have very poor quality of the sleep, which will affect them on the various factor. So we have identified that the diseases which are making them less active physically are the worst affecting diseases for the sleep on any gender. And even if we consider the step count, like if they are physically active, does it mean anything? Like, is it going to affect the sleep quality? We have identified that even the males are walking more and compared, which is giving them better sleep. So the better walking is giving them, if they're active physically, it is giving them the better sleep. But if we come to the females, even though the females are walking better, and even though they are obese, they are walking better, but still their sleep is very less. So we can identify that. But for the males, if they are physically active, they can sleep better. But if we come to the females, the emotional is the main problem. Like the widow females, even though they are walking more with the 2,200 steps when compared to the single, but they still have the less sleep, as we have seen in the previous slides. So for the females, the emotional related problems are the main concerns regarding the sleep quality. If we come to the limitations of our study, we can see that we have taken our data set from the MI band, like the wearable device. So and this research is focusing on elderly people. So there might be like the limitation of they might not able to appropriately adopt with the technology of these watches. Like some of the old people can't see properly and they're uneducated, so they can't adhere to this wearable technology. And even these devices also, they might not have the proper trust in them. So this is one of the drawback. And the sample diseases, even this we have focused on our research on the most 7 diseases. So if there is any more samples concerning the less prominent diseases also, so we might get some variety of the insights from that study. So that is one of the limitations. So if we conclude what is the reason, so why we are doing this, so what is the use of this, excuse me. Yeah. So if we conclude our study, so we can get the insight. We got the insights regarding the males and the females and everyone with the different BMI and with the physical activity status. So we can make this as a framework or the backbone for the machine learning models or the AI models with the mobile health technology. Like we are planning to create some mobile apps, and based on this data framework, this is the backbone for the algorithm. So they get the digital interventions, like the digital health insights based on their BMI status, their gender, and their disease. So we are planning forward to do this as a future work, so that they can get the advantage of the AI with a responsible manner. These are the few of the references, and thank you for everyone. Thank you for your time. Any questions, please?
That was a good presentation.
Thanks for your presentation.
Thank you, sir.
With respect to the machine learning models that you're planning to develop based on this, so what are the kind of models you're planning to build? Is it some kind of clustering methods, or is it going to be some kind of recommendations which can motivate the people to deal with the issues? So what kind of models are you planning to build?
The second one is, you got it, sir. So we are going to give the recommendations based on the insights or the framework, like based on their gender status and their martial status and their disease and the activity status. We are going to just give the recommendations on an app.
Okay.
Yeah. Did I answer your question, sir?
Yes.
Thank you, sir. Thank you for raising the question.
Do we have any other question? Okay, thank you. I think we can move on to the next presentation then.
Thank you. Thank you. Thank you, sir.
Yes, now we can invite the paper ID 59, the presenter Chetan Landy, and the paper title Text Echo Dynamic Voice Generation for Personalized Text-to-Speech System from Dr. D.Y. Patel Institute of Technology, Pune. You are muted. You please unmute yourself. Chetan.
Am I audible?
Yes, you are audible. Please share your screen and start your presentation.
Okay.
Chetan, your screen's not visible. Yeah.
It's okay.
Yeah, now it's visible.
Okay, now visible it's okay, thank you. So good afternoon everyone.
Can you put it on slideshow mode?
Student. It's okay?
Not yet. Actually, you have shared only the PowerPoint file. Please share the entire screen and proceed for slideshow.
So it's okay now, the screen?
No, the slideshow is not
We can see
visible. I
only your
can see the
PowerPoint.
PowerPoint.
When you are sharing in MS Teams, please share your entire screen. Stop sharing in Teams and then reshare with your entire.
Yeah, I can do one more time sharing. Now it's okay.
We can see your folder. Please go to your PowerPoint.
Okay, it's okay now for the presentation.
No, your slides are not visible. I can see your desktop screen.
Chetan, open your presentation. Your desktop is your.
Share your entire window.
Yeah, and just go to the slides.
Now it's okay for presentation.
Please make it full screen.
It's okay now?
Yes.
Okay.
Okay, so let's start the presentation. Good afternoon, everyone. I'm Chetan Landia, Computer Engineering at Dr. D.Y. Patil Institute of Technology. Present my paper Text Echo, a dynamic voice generation for personalized text-to-speech systems. Authors are Dr. D.Y. Patil, Ms. Vasudha Faltankar, Ankur Bombade, Shuprasad Wagmare, myself, Omkar Raskar, and we are all from the Department of Computer Engineering, Dr. D.Y. Patil Institute of Technology, Pimpri, Pune. So these are the introduction of our project. So background study of the project. The
Sorry
evaluation
for the interruption, Chetan. Sorry for the interruption. We can see only your PowerPoint file, not the slideshow. I think you have shared only the PowerPoint stuff. When you share it in MS Teams, please select the entire screen. You click on share, there will be a screen option. Please select the screen option.
Got it, got it. Entire screen options.
Chetan, start the slideshow.
Yeah. So moving forward, introduction point. So background of our study, the evolution of text-to-speech technology spans decades, transition from early robotic sounding systems of the 1960s to modern day human-like speech synthesis techniques, early methods that are used in text-to-speech systems, that is concatenative synthesis and hidden Markov model, that is HMMs. However, advancement in nowadays in a deep learning model such as WaveNet and Tektron have significantly improved a speech fluidity and naturalness of the speech. The basic information and our main aim of the project is to convert a written content such like PDFs, images into a natural speech that supports a multiple Indic languages. So move forward. So there are the suggest solutions of our projects. The personalized voice generation with user input, enhanced ethical and privacy standards. Why this project needs? So improves accessibility for regional language speakers such like Marathi, Hindi, Bengali, Tamil, Telugu, Kannada, the Indic languages. Enhanced personalization in text-to-speech systems to provide option of user-specific voices, address gaps in existing technology of text-to-speech systems. So here is the commercial differences of our Google Speak and our invention. So there are the features like in voice synthesis, we can provide an option of user-specific voice. In Google Speak, there is only a predefined voices only available. In text extraction like OCR, we provide advanced OCR for text extraction from various sources, like the images, the complex images, the literatures. While in Google Speak, there is a limited text extraction capabilities like Google Scan that not enhancedly improve for the images. Support for regional languages such as the Marathi, Hindi, and all the Indic languages. In Google Speak, there is a limited support for regional languages. It is not impressively good in the Indian languages. The interface, we provide a simple and user-friendly and easily options like voice recording, document uploads, and customization options. In Google Speak, there is a standard interface with fewer customization options. The usability of our invention is easy to use for individuals with varying technical expertise. In Google Speak, there is requires some level of technical knowledge of for advanced features. The motivation behind our project is the challenges that we need to address in text-to-speech system, like lack of proficiency in Indian languages like Marathi and Hindi, offer a limited user customization support. It is inability to capture emotional experiences in synthetic speech, ethical and privacy concerns related to the data of voice of user, the related works, the research efforts in the text-to-speech systems, the early approaches as we seen in the introduction section, the concatenative synthesis and the hidden marking models are the first approach for the text-to-speech systems. The modern techniques in this right now, the WaveNet and Tektron, the deep learning 2 algorithms are used for the enhancing the speech quality, which is a revolutionary step in the text-to-speech system. A voice assistant text summarization is an application that utilizes Python text-to-speech library to enhance user experience to multi-voice support. And the vocal apps, the aids vocally impaired individuals using a long short-term memory bidirectional, achieving a 96.97% of training accuracy. The text-to-speech application that employs a GPT for the style control and achieves 87.9% of accuracy in emotional expressions. Here is the literature survey of our paper. So here are the various publication sources and paper application papers published in these sources like voice assistant text to speech summarization using NLP, vocal SAP, text to speech, and speech to text and text to speech recognition using deep learnings. Here are various methods used in this paper's application and their results, their achieved accuracy, and the research gap that we need to fill in our project, like limited real-time data integration, personalizations, complex functionalities, insufficient emotional data, diversity, need for better awareness, handling diverse accents and languages. Here are the main paper that we used for our research, that is Springer 2020, a review of text-to-speech systems for Indian and non-Indian languages. The methods uses systematic with Prisma and model like WaveNet and Tektron. Notably, the results are the advancement in across multiple languages, and the gaps that are found in this paper is limited non-English TTS focus and not practically implemented. The proposed methodology of our project. So data set that we used in our project, that is Indian TTS, that is created by the IIT Madras, LJ Speech Library TTS datasets that are publicly available datasets, and we were used for training the model. So they are creating programmable language specific datasets, creating customizable datasets for Indian language. It is very important to enhance the speech synthesis, such as the datasets includes original slangs, dialects, poetic variations to guarantee to provide a more accuracy in speech synthesis for TTS system. The tools and technologies used in this project like OCR, Tesseract OCR for text extraction from images and PDFs, voice recorder, and the database. So here is our block diagram of our project, like start, record voice, user uploads a file, PDF image, then the extract the text from a file from PDF. If there is an image, then we use a OCR processing, and the extracted text is converted to our system by using a custom voice model. For this, we use a Tektron 2 and a WebNet algorithms, and then we provided this voice to the user. There is two options, a play or save a generated audio. So there are some things that we need to addresses in this project, that is privacy and ethical safeguards. For that, we provide a user consent, a voice data collection, and watermarking to prevent the misuse of the voice of user. And evaluation matrices that are used to calculate the accuracy of our project, that is mean opinion score, word error rate, and phoneme accuracy. Also the latency accuracy. The proposed methodology, for that we use two algorithms, Tektron 2 and WebNet. So Tektron 2 is typically used for creating the MEL spectrograms. It is a text to spectrogram generation. Tektron 2 employs a sequence to sequence model with attention mechanism to convert a text into a MEL spectrograms. It's representing the frequency of spectrogram of sound. This model maps text characters like phonemes, slangs, regional accents, emotional touches of the characters to acoustic features, thereby capturing prosody, rhythm, and intonation. And wavenets, after the implementation of the Tektron, we uses the wavenet to create a natural voice generation. And the Tektron 2 and wavenet, by pairing these two algorithms, we enhance our project's model. So here is an in-depth system working as system architecture of our project. If you see, there is option of user interface. We provided two options: upload a PDF image and a record voice. For a record voice, we use algorithm audio recording pre-process to clean the data set of the voice. For use NLP process tokenizations, and we provide upload or PDF image option here. If there is a PDF, there is no extraction of the text. But if there is an image, there is an extraction of a text. For that, we uses the OCR algorithm. And all the extracted text is stored in the databases. And here is the option of Here is the all in the user interface interaction. Then the second one is a text to speech conversion. The database text was processed for speech synthesis using advanced TTS algorithms such as Tectron2, WaveNet, fast speech to produce a natural sounding speech. As we see in the last slide of Tectron2, it converts a text into a mail spectrograms. And WaveNet, it generates a realistic and a natural sounding speech waveforms and fast speech to enhance our speech synthesis real-time performance. Also, we provide a output in two forms, the real-time output, and we stored the output offline mode to access after in our system. So the audio is stored in the databases. So if user want to listen the voice, then they can go back in our project and they can listen to the audio. So the experimental results we can draw from this project as we as we implemented one survey for this project. It is a pre-survey for our project. So we got these results actually. So first one is performance of accessing book by user. So users of the 83% user chooses the listening over reading, and 60% of the users chooses the reading. That is 60%. And there are slide is sum for the both percentage. Here is an application used by user. Every day it's up to the 48%, sometimes is up to a 44%, and never there are something little bit up to 8%. The mean opinion score, as we described further in our evaluation matrices, for the Marathi language, current TTS systems provides a 4.0 mean opinion score. Our target to achieve it's a 4.4 mean opinion score. For Hindi language, as of now, it's 4.1 for the TTS system currently working, and for our target is to achieve a 4.5 mean opinion score. So here is a survey results. What user value most in a voice tool? So there are the three options: clear voice for 62.5%, fast conversion of voice, that is 20.8%, and easy to use is for the 16.67%. So here are the expected results from Indian languages, Hindi, Marathi. Here is the current TTS systems, and it's our text echo expected outcomes. So for the word error per rate, the TTS systems currently working, it is above 5, but our text echo provides less than 5. It's nearly to the 4.2. And it is a phoneme accuracy. So the current TTS system that works, it's up to the 87.72% phoneme accuracy. But our text ecosystem provides is up to 92% for the Indian languages such as Hindi and Marathi. So we conclude that our text ecosystems is an innovative tool designed to turn written text into a clear and friendly voice. It is especially beneficial for people who have difficulty in reading or seeing, making information more accessible. And its applications in schools, hospitals, and travel, ensuring that everyone can easily access the information in their own languages. So here are some future works. The language expansion, such as in all Indic languages, Punjabi, Bengali, Malayalam, Telugu, Tamil, Kannada, and all over the Indian Indic languages with their regional slangs. The translation integration tool we can integrate with our project, the API development of text echo, and the enhancements, conceptual enhancements of our project. So there are the future works. Here are our references that are used in our projects. Thank you.
Okay. Thanks for your presentation, Chetan. I have a few queries on your presentation. First thing, when you convert this text to speech, actually, how do we pronounce each and every words in each language? It's a difficult component. So how do you address that issue? How do you train your model in order to pronounce it in a correctly?
Okay, so I will provide some guidelines for that to provide voice for that, and we pretend voices for regional slangs. Actually, we create data sets for each specific languages with regional slangs, their phoneme accuracies, their emotional touches, and by using this data set, we can addresses these problems.
What is your data set size? For example, let us take one language like Telugu or Tamil. And what is your data set size for that language?
Actually, we provide a bulk of our data sets, and we have the data sets have the specific features like regional slangs, the emotional touches, the intuitions, we see the accents for the particular languages. So the data set is validly more, and we have to train the data sets for to getting the correct accuracy, and we addresses these problems.
Okay. So, what is your proposed technique for generating the voice from the text?
We here, as we see in the PPT, we use two algorithms. One is Tectron 2 and one is WaveNet. By using these algorithms, we generate a voice.
Actually, the work what you do in an innovative way, like with the data set, reprocessing, and algorithm for this, these are not reflecting on your title of the paper. So try to normalize your title to reflect your techniques that you are using to convert this text to speech. And similarly, you have pre-survey. Try to have a post-survey with your system to validate the results.
Actually, our project in now in implementation phase. It's a final year computer engineering, Bachelor of Engineering project. So it's now in the implementation phase. After the implementation, we do the post survey also.
Fine. So that's it from my side. Over to the organizer in offline mode.
Yeah, any other questions?
You are muted.
Yeah, no questions. I think we can move on to the next paper, that is paper...
Over to Mangalore University.
Yeah, paper 70.
You are muted. Fine. Then, we can move on to the next paper. Thank you, Chetan.
Thank you very much.
Now, I'd like to invite the authors of paper ID 70, the presenter Hamada Balal Ebi, for the paper titled An Experimental Comparison of the Effect of Text Preprocessing for Sentimental Analysis Using Ensemble Model from Wallace Institute of Science and Art, University of Wallace, UK. Yes.
Hello. Good afternoon. Can you hear me?
Yes, we can hear you.
Thank you so much. Well, I'm going to present the paper number 70. Let me share my screen, please. Can you see my screen, yeah?
It is getting started. Yes, please make it as full screen and proceed.
Let's make it full screen.
That slideshow.
Sorry, I'm trying to make it full screen, but I'm not sure.
Just display settings. In the top display settings.
Yes.
Just click on it and swap. Yeah.
Okay. Is it fine now?
Click on swap. Yes, now it is fine. Please proceed.
Thank you. So I'm presenting the paper, an experimental comparison of the effect of text preprocessing for sentiment analysis using ensemble model. So first, a short introduction. So the aim of this study is to explore the role of text processing in sentiment analysis, and trying to understand its impact on the performance of deep learning models, especially focused on an ensemble model applying backend techniques. So the idea emerged as the fact that sentiment analysis it's a crucial task in natural language processing, enabling automated system to identify and classify emotions through the analysis of text. Initially, as the practice of sentiment analysis started from basic binary classification using different kind of models such as convolutional neural networks, LSTMs, GRUs as base models. But more recently, these models have evolved to more complex model applying ensemble techniques in order to combine the results from different models. Uh, these models are supported by effective text preprocessing techniques such as tokenization, support removal, lemmatization, stemming, and we will see more of them during the one that we used for this research. So meta-ensemble approach have been significantly improved the sentiment analysis. So the idea is to combine different the prediction from different models and try to get the best of each one of the models to try to aggregate the prediction and achieve better results. There is actually large number of research in the topic, especially focused on different kind of models, on different kind of ensemble approach, and also we can find a relevant number of papers focusing in the text preprocessing part of the process. However, we found that there is not a let's say, an extensive study that focuses on the effectiveness of the application of different preprocessing techniques and its impact on particular kind of models, especially to ensemble models applying bagging techniques. And that's actually the purpose of this study. As I said, we can find multiple works in both the topics, in the ensemble models part of the research, as well as the study of the impact of preprocessing techniques. I selected some of the relevant topics, so we can find some works that have achieved high accuracy, like the work by Hadi that applied TF-IFD feature selection and used support vector machine classifier, achieving 93% of accuracy. We got other models that have achieved as well important accuracies, like Benezet et al. That applied different preprocessing techniques to its models, so to try to understand what will be the best approach. Also, we got different other works that have analyzed different preprocessing techniques. In this case, they use 6 preprocessing techniques, Jianxing and Xiaoling, and focused on their accuracy and score. We got as well different approaches that have managed to apply different bagging ensemble, different ensemble techniques, achieving different results. We can see Tiwari and Nagval applied, achieved 72% of accuracy, applying linear discriminant analysis. Casimir and Van applied as well centi-word-net approach and achieving a 92%. And then we got on all the works that have achieved with different approach of ensemble techniques. In this case, we got Kevanpur that achieved an 89%. So to try to understand how the impact of these some preprocessing techniques applied to some text preprocessing techniques, it's directly affecting the results in for different models, especially focusing on 3 kinds of models that we will see right now. So the idea is to combine 7 different preprocessing techniques. Lower casing, stop word removal, punctuation removal, lemmatization, stemming, tokenization, and padding sequences, and see how they affect to 3 base models, CNN, 1 LSTM model, and 1 GRU model, and then apply an ensemble model based on bagging techniques, and compare what is the impact of each one of the preprocessing techniques and different combinations of them to see how they affect the final results. So, as I mentioned, the proposed preprocessing techniques used in this study are basically lower casing, which is specifically to unify the lower casing in the text, so we don't have uppercase and lowercase, just one kind of just a lowercase in the text, just to simplify this feature for the models. Then we got stop word removal, which is focused on the which applies actually removes the words that are not meaningful for the text. Then we got punctuation removal, which basically removes punctuation, levitation, which is focus on the on converting the words to the base form. We can see in the example that the cats are rabbit will be converted to the cat bearer, so getting the base form of each word and to be feed to the model. We apply also stemming, which which converts the words to the root form, which is a different case than lemmatization. In this case, we can see that it's focusing in the infinitive form of the verbs, as well of converting the nouns to singular instead of plural, and these kind of approaches. Then we apply tokenization, which is converting each word in a token to make it easier to be processed by the model. And we apply padding sequences, which focuses on uniforming the length of each segment of tokens that will be feeding the model. Then we have used three base models. As I said, we have used the convolutional network that has applied one-dimensional layer, convolutional layer for local feature extraction, and one global max pooling layer to highlight key feature. It passes through dense layers for full delinear and applies binary classification using a sigmoid function. We have used also a long short-term memory model, which comprises an embedding layer with 128 dimensions and an LSTM layer with 128 units, and it applies a dropout rate of 0.5 for both regular and recurrent connection, and also applies binary classification representing positive or negative sentiment. And finally, we applied also a gated recurrent unit model with as well 128 dimension and 128 units, dropout rate of 0.5, and applies sigma activation function for binary classification as well. Then at the last step of the study, the experiment, we applied the banking techniques to to retrieve the resultant results from the metadata sets, so the result of each one of the models, and we applied sample averaging to aggregate the prediction results from each classifier. And no extra weights were applied, so we gave to each one of the base models the same weight for this study, for this experiment. We used the IMBD data set, which is a data set that comprises 50,000 binary movie basically positive or negative reviews. It's divided in 25,000 positive and 25,000 negative reviews, so it's a very balanced data set. It applies, so it can provide from short sentences to large paragraph for each review, so it provides it provides a wide range of diversity. We ran the experiment using Python. We used some Python libraries as NumPy, Pandas, Keras, and Tensor. And the experiment was run in a computer system with an Intel processor, Intel Core i5, and 16 gigabytes of RAM. So the experiment expanded the impact of 7 preprocessing techniques in differentiation. We will see these in the next slide in the table. We split the data into training and data in datasets, and we adjusted the hyperparameters to fit our requirements. Each base model, the CNN, LSTM, and GRU models were trained independently, and then afterwards the prediction were averaged using a custom backend classifier. So in this table, we see the multiple combinations that we have run in our experiments. So 32 in total. We have focused on focused on understanding how deep is the impact of lowercase stop or removal, punctuation removal, lemmatization, and stemming, and the different combinations of these 5 preprocessing techniques applied to both tokenization and pattern sequences, which result in 32 different experiments, and we managed to get the result from this experiment out on how was the impact of each one of the preprocessing techniques and their combinations. So we got some interesting results. So we understood that for the CNN model performed well just with tokenization and padded sequences. So it didn't require too much, didn't require the rest of the text preprocessing techniques. And it also noticed that it was performing even worse for when applying too many preprocessing techniques, which could lead to a loss of features, as the CNN model can rely heavily in the feature extractor process part of the process. The LSTM model achieved its best score with stopword removal, punctuation removal, tokenization, and pattern sequences. On the other hand, the GRU model showed the strongest performance with lower quotient lemmatization, tokenization, but staggered with other preprocessing combinations. And finally, the Baggy model, we found that it was best performing with lemmatization, stemming, tokenization, and pattern sequences. These results will be presented later in a table. We found that lemmatization and stemming, we found to enhance the models by reducing disasperity for all the models except for the CNN. As I said, the CNN was relying heavily in the feature extraction part of the process. The tokenization and pattern sequences was actually universally effective, while lower casing and punctuation removal provided a moderate improvement to the models. And then finally, when we start comparing the performance of different models versions, we found that the bagging ensemble model, while generally more stable, was more sensitive to preprocessing choices compared to the CNN model. The CNN model was performing best with minimal preprocessing settings, so which can lead to understanding that was due to the limitation, due to the fact that the CNN will need to extract its own features from the data set. So in this table we have compared different versions. We have managed to achieve some proper results for each model. We can see that the ensemble model achieved highest accuracy with 90% of the in the version 20 of the experiment. Then we can see also as well that other models like the CNN achieved also 90% in the version 9. So we have seen for some of the experiment that so from combination, the ones that we explained in the slide before this one, we managed to achieve high rates of accuracy and as well as precision and F1 score, achieving rates of 88, 89, and 90% of accuracy in all the metrics. Well, this is this slide we're just explain graphically what we have just shown in the tool, and an insight of what the results were from the experiments. As I said, we can find good results from 8 above in different versions of the experiment. As a conclusion, we can say that this study managed to evaluate the effectiveness of various preprocessing text in sentiment analysis using assembly learning. We understood better how different text preprocessing techniques were impacting directly different models. We found that the CNL was improved. The CNN model was handling minimal preprocessing text very well, providing very good results without minimum with the minimum requirements of preprocessing techniques applied. Was different for the LSTM and GRU models that are sensitive for different techniques. And the approach, the one that most, as it was taken actually results from the 3 base models, it was basically the one that was more consistency over all the experiments, and that the the text preprocessing techniques are not always required. I would say that are not always it need to be applied. Sorry. Basically, we will have to choose carefully which text preprocessing to apply based on the model and the requirements of the experiment or the requirements of the model used for the sentiment each time. There are some limitations in this study. We used just the IMBD dataset. For the work will imply to test the same kind of experiments with different datasets, with more complex datasets. Also, the future work will involve to explore different models or different bagging techniques, not just different ensemble techniques, not just bagging techniques, but others like stacking or boosting, as well as different model for the base model rather than CNN, LSTM, and GRU models. Those are the references that we have used for this presentation, and thank you so much.
Yeah, thanks for your great presentation.
Thank you.
So it's an experimental comparison, right? So you have taken one data set and tried with all kind of models with the concept of ensemble. Okay, so in the case of sentiment analysis, so what kind of variety of data you do have in the data set?
Sorry, can you repeat, please?
Oh, here the major focus is on sentimental analysis on the text pre-processing. So from the text, you identify what kind of sentiment it is, right? So in the data set, so how many possible choices has been given for each sentiment?
Oh no! So just it can be just a positive a positive review or a negative review. So just in this case, we have applied just two possibilities for the output. That will be also a limitation of this study. Further work will require also to apply this to neutral reviews or more ambiguous reviews, I would say, rather than just positive and negative reviews.
Okay, so it's like a binary model, either this or that.
Yeah, binary model. Yeah, actually.
Okay, okay. So how many sentiments you have considered? Like whether you classified any more onto it or only positive and negative?
No, only positive and negative.
Okay, okay, understood. Okay, that's it from my side. Over to the organizer. Any other further queries or discussions from the organizer?
No questions here.
Bangalore University.
All right. So I think no other questions. So we can move on to the next presenter, that is paper 72. Gauri Ratnawat, sequence prediction.
No queries. Thank you so much for your presentation and your time.
Thank you.
Let us move on to the last paper of this session.
Yeah, that's sequence prediction and anomaly detection for satellite telemetry.
Yes, so that's the last paper from Gauri Ratnawat from VIT Bhopal University.
Yes, sir. Good afternoon, everyone. Myself, Kanak Sharma. Is my screen visible?
Yeah, please make it full screen.
Yes, sir. Yeah, is it visible?
Yes, yes, you can proceed.
Good afternoon, everyone. Myself, Kanak Sharma from Vellore Institute of Technology University. First of all, I want to show my gratitude for this opportunity. And myself and Gauri, our Professor Vipin Jain, and under the guidance of him, we have conducted this and prepared this research paper, sequence prediction and anomaly detection for satellite telemetry. So basically, in a modern satellite operations, it's basically ensuring the health and reliability of satellite system and paramount. Our project addresses this challenge by detecting anomalies within large multivariate time series data from the control anomalies time series dataset. So, this research basically focuses on detecting anomalies in multivariate time series data using CATS dataset. which consists of 5 million timestamps and 8 attributes related to telemetry and commands with 200 known anomalies for testing. We follow a comprehensive approach that combines both classical and advanced machine learning techniques. This includes isolation forest, LSTM networks, and RNN. First, we pre-process the data by standardizing the features and marking the known anomalies. Then we conduct exploratory data analysis to visualize trends and correlations in the data. To evaluate the performance of our models, and deep learning models are effective detecting anomalies, each with its own strengths. This research basically highlights the importance of feature selection and model tuning for achieving optimal performance. In this study, we use comprehensive approach that combines machine learning models like isolation forest, random forest, DBScan, and KNN, alongside with deep learning models such as LSTM and RNN. Our workflow basically includes data pre-processing, elaboratory data analysis, anomaly visualization, and performance evaluation using key matrices like precision, recall, and F1 score. Our main goal is to improve the detection and prediction of anomalies in satellite telemetry data, enabling early identification of issues before they cause any major problems. Anomaly detection is essentially in identifying unusual patterns in data that deviate from expected behavior. It has a wide range of applications in fields like finance, healthcare, cybersecurity, and industry. Whereas, like helping to early detect can prevent significant losses and enhance operational efficiency. With the increasing volume of data in these fields, we need powerful and anomaly detection methods capable of analyzing large multivariate time series data. Our motivation for basically this project was, in our study, like we focus on scarce data because it's like the project is to create a system that can detect and predict problems in satellite operation before they happen. Satellites play a crucial role in our communication, navigation, and space exploration. So identifying issues earlier can prevent failures and reduce risk. Since satellite data is large, complex, and time-based, traditional methods struggle to find hidden problems. This inspired us to use advanced machine learning and deep learning models like isolation forest, DBScan, random forest, KNN, LSTM, and RNN. These models can detect unusual patterns in the data, helping in identifying potential issues related to that. By building a comprehensive framework that incorporates data preprocessing, feature selection, model comparison, and performance evaluation, this project aims to not only improve on anomaly detection accuracy, but also support real-time anomaly prediction. This proactive approach can alert operators before anomaly occur, ultimately contributing to safety, efficiency, and reliability of satellite missions and other crucial real-world systems. For the literature review and the related works which has happened before, like firstly, there's a dynamic prediction models which predicts data trends and automatically adjusts the thresholds. And the other one was hybrid approaches for accuracy done by Zheng. Combined causal relationship with attention-based models to reduce false alarms. Machine learning for monitoring systems basically is using enhanced health monitoring with deep learning to detect abnormal behavior and forecast issues. Other technologies, Wang used time-based models for large-scale telemetry data, and Zheng used simplified raw data to extract patterns for anomaly detection. Basic methodology for this was, first step was data processing. The data set is loaded using pandas, and pre-processing is formed to ensure data quality. Known anomalies are marked based on provided metadata CSV file. A subset of file features examples like attributes like BFO1, BFO2, BSO1 were all selected for contribution across features, which enhances model performance. Second step was elaborative data analysis. EDA is conducted to identify patterns, trends within the dataset. Basically, key visualization include correlation heat map, which highlights the relationship between the features and anomalies, and time series plots, which reveals trends and fluctuations. Third step, we have done anomaly detection. Two key models, isolation forest and DB scan, are employed for anomaly detection. Isolation forest identifies anomalies by isolating data points that data differ from majority. It uses a contamination rate of 0.006 to 0.04 to control the proportion of data points classified as anomalies, where higher value results in more points flagged as anomalies. A second is the DB scan. DB scan identifies anomalies as low density points that do not belong to any cluster using Epleson range of 0.6 to 0.8 and a minimum samples of parameter to 18 to 25. The model clusters dense regions and labels sparse regions as anomalies. The last step was analysis and visualization of anomalies. The detected anomaly are visualized using 3D scatter plots generated after dimensionally reduction via principal component analysis. This enables a clear visual differentiation between known anomalies and those detected the models. A comparative analysis is performed to access the anomalies detected by isolation forest and DB scan against known anomalies. Both methods achieve a detection accuracy of 96%, demonstrating their effectiveness in identifying anomalies in the dataset. Here is the anomaly detection and prediction project overview. First, we load the data, mark the anomalies. Anomaly detection has been further conducted. Selected features, use isolation forest for anomaly detection. Then we use DB scan. Further, we label the detected anomalies. Next, we do data pre-processing to prepare a data for prediction. We split the data into train and test sets, scale the features. Further, we model the train. We do the model training and prediction. We use random forest, KNN, RNN, and LSTM. In the last step, we evaluate the data. So here are the experimental results, which we basically the comparative evaluation shows that random forest outperformed other models, achieving 100% accuracy with perfect precision, recall, and F1 scores. Its ability to handle non-sequential tabular data makes it ideal for CAD's dataset. Random forest is also computationally efficient and resistant to overfitting even in noisy or imbalanced datasets, making it suitable for real-time anomaly detection. On the other hand, LSTM and RNN models designed for sequential data struggled with the non-sequential nature of the CAD's dataset. These models require larger datasets to avoid overfitting and improve generalizations. Overall, the proposed approach using random forest is efficient, less computationally intensive, and enables fast, accurate anomaly detection with minimal resources. These are the diagrams for the anomaly detection. We have used BSO2, the attribute showing the isolation forest, and the red ones are the anomalies, the blue are the normal ones. For the DB scan, the figure 3, and further we have the confusion matrix for KNN, and we have the confusion matrix for random forest. This is the confusion matrix for KNN shows the true positive, true negative. Further, for the normal anomalies which showing normal are the shown in the dark blue. Then the anomalies which are normal but shown as normal, which are shown as anomaly, are 4,296. Like this, we have done for the KNN and for the random forest. The accuracy of other models are shown here. Random forest has the accuracy of 99%. KNN has accuracy of 99.9%. RNN has 98%, and LSTM has 98 also 98%. Further, I would like to conclude the study. The study basically demonstrated the isolation forest and DB scan achieved highest accuracy. as average came as 96%. For anomaly detection on the cache dataset, outperforming deep learning models like LSTM and RNN, which still showed promise in capturing temporal dependencies. For future work, integrating assemble techniques that combine multiple model architecture could enhance accuracy and robustness. Real-time anomaly detection should be prioritized for application such as industrial monitoring and space exploration, potential through online learning or incremental updates. Exploring transformer-based models may further improve performance by reducing a computational load while maintaining high accuracy. Additional applying dimensional reduction and transfer learning techniques will help to handle complex high dimensional data sets, making models more scalable and adaptable to diverse scenarios. Thank you so much. These are the references, and I would like to conclude. Thank you.
Thanks for your presentation. Actually, you have done a comparative analysis with the existing models, right? So,
Yes, sir.
so that you can reflect in your title of your paper too, because it's so generic, like sequence prediction and anomaly detection for satellite telemetry. Okay, but what is your core component is comparative analysis of the existing models with this data. So
Yes, sir.
you can reflect those things in your title when you revise your paper. And okay, so when you do training, you try to give a knowledge to your model that these are the things are considered to be anomaly, right?
Yes, sir.
So like that, how many kinds of anomaly you have considered?
So in our data set, we have 200 known anomalies, and we have used the anomalies which are going out of the boundaries, like the normal datas. Like a simple example of temperature. If the temperature during a week, we are using the week data over here. So during the weekly data, the normal temperature which are being observed is being marked properly, and the temperature which is going outwards, like which are not being frequently observed, is been marked as red. So therefore we'll conclude that as an anomaly, and not the ones which are like followed normally in the basis.
Great. Appreciate your efforts. Thanks for your time and presentation. Over to the organizer.
Thank you so much.
Yeah, no questions here.
Blue
I would like to
University.
thank all the presenters and also thank you, Dr. Murugan. So we'll move on to the next session, and I hand over the session to Dr. Manoj Gadyar.
Yeah,
afternoon,
thank
everyone.
you all. Thanks for the opportunity, and thanks for all the authors for the good presentation. Thank you all.
Thank you. Good afternoon, everyone. Now we are going to have one important invited talk by Mr. Sapnil Bhatnagar from INSAIF, UK, London. The session will be chaired by Dr. Uday Kumar Keshanai, Professor and Dean Research and Development, Canara Engineering College, Mangalore. He has over 7 years of his experience, industrial experience, followed by 22 years in teaching, and he has 50 plus publication in his profile. A renowned researcher and academician. He has, to his credit, 2 students who have already done their PhD, and his area of expertise and research is IoT, wireless sensor network, and cloud computing. Yes. And Professor, Angesh Anupam is also with us from the Cardiff University, and I would like to hand over the session to Dr. Uday Kumar Shane.
Yeah, rather than taking the session, I would like to introduce today's invited speaker, Mr. Sapnil Bhatnagar. Sapnil Bhatnagar is a technical product manager at INSAIF, London, UK. He is specialized in digital AI SaaS products with deep expertise in product strategy development, product vision, and implementation through agile methodologies. He has led critical digital transformation projects for AI-powered SaaS platforms from concept to delivery using agile and rolling wave planning. Mr. Sapnil has established AI-enabled features for the top 20 corporate clients at Insife, significantly enhancing their product capabilities and business value. He has implemented robust AI product discovery processes, aligning advanced machine learning solutions with the user needs and business objectives. His expertise include AI SaaS product development and deployment, product vision crafting and strategy, value optimization for machine learning solutions, AI feature prioritization and road mapping, project management, team leadership in agile environments, stakeholder management for AI initiatives, value creation and integration. Mr. Sapnil Bhatnagar has had his master's from UCD Smurfit, Ireland. Sir, the floor is open for you. Mr. Bhatnagar will be presenting his invited talk on decluttering advanced RAG in building federated systems for digital products. So over to you, sir.
So hello everyone, I'd just like to do a quick sound check. Are you able to hear me and see me fine?
Yes, you're audible, Sapnil.
So thank you very much for a wonderful introduction early on. And I was fortunate enough to listen to conference papers that were presented early on. Pretty interesting insights coming in from there. Those are exactly the use cases that we work in the industry as well, scaling our products for our enterprise customers. Unfortunately, some of those techniques are being used by enterprise customers such as Pfizer and Novartis. That is also in my background that I did early on in the year 2022 as well. So I'll give a quick background myself. I'm a technical product manager at Insight. We scale our products for enterprise customers. SaaS enabled platform. Our ticket size range anywhere from $100,000 to a multi-million-dollar deal on a multi-year cycle for product implementations. Although we do not specifically do a lot of research work within the organization, the objective is to incorporate research into the product and then scale it for customers. And then some of the interesting work that we do in the industry is around pharmacovigilance processes, which means we are looking at patient outcomes on a day-to-day basis and then generating insights out of our products for regulatory and compliance needs. Prior to this endeavor, I was a startup founder with Connecting Traveler, where I developed their entire travel experience platform that could connect travelers to travel influencers. So when we scaled that up to almost 7 lakh visitors on the platform, 2,000 plus odd registrations on the platform. So, and then we went on to incubation centers as well. So that's a little bit of background that I have. And I'll be sharing my screen with you. If you just help me once it's visible, that would be great. I am sharing my screen. If you let me know if you can see it. Maybe a like button on the Teams channel would be great because I cannot hear you.
Yeah, Sapnil, the screen is visible.
Okay. Thank you very much for the confirmation. So I'll just quickly introduce the topic for today, and this is also how we will be setting the tone of the agenda, which is decluttering advanced RAG in building federated systems in your digital products. Now, this might sound a little bit convoluted, but I'm pretty much convinced that within 30 minutes time, you will understand the enterprise application for a RAG and how we are utilizing in the industry as well. Just to set the tone of the agenda today, we're not going to be diving deep into the research level that may be better suited for people that are in the academics. Maybe we use that research onto our platforms. The agenda today would be more on the higher layer of abstraction, where we look at it from the product development and discovery perspective. So our ideation And our cycle for today's session will span across an enterprise use case. So that's the topic. And what we'll be covering today is what are the challenges that these organizations are facing right now with enormous amount of data that we have available in the industry. And then we'll introduce some data introductions as well. Then I'll move to how LLM customization stage, where we'll explore how LLMs are helping enterprise customers really solve this challenge of fragmented data set. Then we'll move into a vector database, RAG pipeline, and a process flow of developing a RAG pipeline where I'll be introducing a lang flow product that you could use and maybe learn in a day's time if you've got background in machine learning and RAG application and product development. And then we'll conclude with RAG use cases. So if that sounds interesting, I'll move to the first section, which is organization challenges and data introductions. So let's imagine you're sitting at a larger enterprise organization, something for likes of a Google, Microsoft, or a Pfizer or a Novartis, and the amount of data and the number of documentation that is available inside the enterprise spans across terabytes or even zettabytes of data. Now, organizations are really losing a lot of value unlocking insights from these data because, first, this data is either unstructured, too scattered, too fragmented, has got no headers associated with it, and there is no metadata available so that you could not extract the data to generate an insight. And here, if we introduce that data on a higher layer of abstraction, we would see on a top level, you can have data in two different categories. First is structured data. We all love it. We want structured data to be part of our organization because we can easily understand that data, have that stored into databases, our Azure framework, and then use it for generating insights. But the problem really lies with unstructured data because you might have thousands of PDF being stored in a SharePoint that nobody is able to use, and images, Word document, Excel documents, and maybe an audio file if you are really an organization that works with customer support services or text processing services. Surprisingly, the structured data is very less within the organization, and 80% of the data that lies within the organization is unstructured data, which means the paramount problem for organizations is how do you extract meaningful information from all of this unstructured data and then use that information to first save cost, increase top line or revenue in your organization, and thirdly, how do you make the best use of resources that you have available in your organization? Now, if you are sitting on a larger organization, let's say a Microsoft that can afford $1 billion research team, you might be well positioned to go ahead and play around with unstructured data, maybe develop your own model capabilities. But maybe that's not the best use of time if you've got a 20 million, 30 million annual revenue within the organization and you're just a 100 people team who cannot afford a research organization. So that's where it gets very, very painful. So then we'll move on to what are the problems with this unstructured data. And that's where I introduce this new visual on your screens where in your organization, your data could be stored in an Azure blob storage or an EC2 bucket for an AWS instance, maybe thousands of Slack messages, thousands of Excel files. There are some CFO documents. You might want to generate insight for your CEO because there is a critical business decision that needs to take place, but then you do not have a right access to this data. Also, there's a governance problem as well because people in the organization, they come and go. So the standards that were true 3 years ago are no longer true today. And that is a very big problem within the organization. So how do you extract this unstructured data from your business ecosystem, put that into some sort of a framework where you can have simple text processing or maybe process advanced PDF or images files through your digital product and generate a JSON file or an extracted outcome that could be directly used for your insight within your product or to unlock more value. Now, this is also very important when you are a smaller organization and you want to raise funding or capital within your organization. You're speaking to private equity firms, etc., for them to invest in your business, and you are really struggling to tell them the best about your business. So these things really help. And that's the concept of or the curse of having unstructured data within your organization. So how does an LLM pipeline, or how does LLM will help us generate insight from all of this unstructured data that is lying within the organization, and how the customization of these LLMs can help us solve this problem? So here I'm introducing a very simplistic agentic workflow which you could use, and which we are using it in the organization as well, where we are customizing our LLM pipeline either on the input level. You could either customize your pipeline on the model level, or you can maybe customize it on the output level. Number 2 and 3 are for larger organizations that might have a research team and have got all the money in the world to invest. We are majorly focusing on input customization because that's something which is cheap, cost effective, can scale efficiently, and is something that you could deploy maybe in 2 weeks' time within your organization, experiment with it, fail fast, and then make 2 more augmentation within your product development lifecycle. So within the input customization stage, you could either use prompt engineering or prompt tuning, where you have a set of guidelines that you could use to generate insight from your product, or you could maybe go ahead and develop a retrieval augmented generation model that can extract your organizational data, support it with your large language models that have got billions of parameters already pre-trained on worldwide data set, and then generate an strategic insight for your business. Now, this strategic insight is not only important for your CEOs within the organization or the CEO of the organization, it is also important for your customers, your clients, your user base. If your product directly touches base with thousands and thousands of users on a day-to-day basis, and that's really, really important. We might not want to explore model customization or an output customization in a smaller organizations, or maybe in an experimental organization, because it takes a lot of time, effort, commitment, and we really don't have that level of maturity once you're scaling products at scale and the innovation runs quite fast. So I think at this particular point in time, most of the organizations that are at mid-tier level are experimenting with input customizations and the development of custom RAG models. And like I mentioned, as you move up the ladder and transition from input customization to an output or model customization, your cost and complexity increases, which means you might be able to deploy a RAG model that passes through hundreds and thousands of data for maybe $100,000 in yearly cost. But if you move that into a model customization or an output customization stage, this cost can easily surpass millions or even billions of dollars if you're doing hyperparameterized tuning or maybe more specialist techniques or an R&D work within our organization. So it makes much sense to do a RAG augmentation into your existing product, or maybe develop a completely new application that passes through your unstructured data set within your organization. Now, this is something that you do not have to explicitly develop right now. It is already available in the market. But the idea is, how do you efficiently use it in your digital product? Because you want to optimize the cost, increase the value, increase your shareholder commitment, alongside develop a product that scales and scales fast for other people, either inside or external to your organization. And that's where the concept of vector databases, RAG pipeline, and RAG pipeline comes into picture. Now, I'll just quickly introduce for all the audience here, maybe I like to keep it a little bit agnostic of how a vector database could look like. So let's say you've got text documents available in your organization, you've got video documents available in the organization, and maybe audio per se. All of this cannot be accessed through a simple prompt or through a single user interface, and you might not have all the insights that you want from this documentation. There is like billions of YouTube videos available. How much of those YouTube videos can you actually retain in a month's time within your organization? I think the answer is it's quite difficult. So what if we embed all of the information that's available in these documents, in these YouTube videos, in these audio files, and embed them into a text format, which means we convert the data in all of these documents into vector storage or numbers, associate those vector storage through an index, and then do a similarity search. What if we do not want to search through an exact prompt of the search, which means if I'm looking for a data set that spans across last 5 years sales number, maybe I'm not looking at a specific prompt to write to retrieve the information from those sales numbers. What if I could just say, can you give me a sales number for the past 5 years, and it gives you a very detailed example of where the sales have dipped, where the sales have increased, what kind of expansion we have seen in the product, where the sales is coming from, what is the geographical orientation, what is the hotspot of the sale. What if you could achieve all of that through a single prompt? And that's where these vector database come into picture. They are very powerful. If you can embed all of that unstructured information in an array vector, associate through an index, and are able to parse through all of that information through a singlistic prompt, through your enterprise application, that's wonderful. And that's where we explore the drivers of creating an LLM system that utilizes this RAG model underneath your product ecosystem. So you'll have to, while we are developing something like this, we have to go through an embedding phase, which essentially means you've got an enterprise data. Now we want to generate vectors out of this enterprise data that we can search on. So we put all of this enterprise data that could easily span terabytes or maybe zettabytes if you're talking much larger or geographically dispersed organizations, put that into an embedding service that could come out of an OpenAI API. It's just a simple box. In today's time, it was very complicated maybe 3 years ago, highly impossible for smaller organizations to even think about. So what if you have an enterprise data, you could put that into an OpenAI API and embed that data, create the vectors out of it, and have a vector store that could store all of that information in form of text. Then you just have an input query from a front-end platform. A retrieval service runs on the backend that is more augmented search engine and gives you the output. And all of this is powered through pre-trained LLM models that you do not have to invest effort customizing or invest effort fine-tuning within your organization. It's just a plug-and-play effect, and that we'll explore later on how simple it has become in today's time. And here then we introduce a minimalistic architecture to create any RAG application in your digital product. So you've got a data, you divide the data components into smaller chunks, then you combine that smaller chunk into a context file that is available in your RAG application. You have a prompt that you want to search through this RAG file, and then you parse all of that data into an LLM model that could be a ChatGPT, a Claude 3.5 Sonnet, or maybe a Haiku model as well. And then you generate an output. On the surface, this looks very simple. There is a lot of complexity definitely involved in getting the right output, which means you want to tailor the entire process that suits your business case and kinds of insights that you want to generate within your business. There's a very famous saying that we also use while dealing with clients is if you put in a garbage data inside your model, all you are training your data is for a garbage out model. So the input is as important as the output, and the model just does the facilitation of processing your input to the right standards that you want in your organization. Now here, let's say if you want to create a RAG application within an organization or within your research team as well, that means if you are a researcher, you want to create a new research, write a paper, and you want to read through 20 odd research papers. What if you could do all of that maybe in a day's time? maybe you could just look at specific parameters that you want to read throughout of all of those papers and just use that information to conduct your research. What it does, it enhances your time to conduct research. It enhances your time to market your products as well if you're working in an industry, and it supports innovation at scale. And one of the classic example is of a Google AlphaFold that has come into the market, where a PhD level research could be conducted in less than a week's time by just feeding all of that historical information into the model. And that's the kind of application we are also seeing in the industry. What was not possible maybe 5 years ago is quite possible now. Clients are reducing on their annual churn or annual budget significantly. And we are seeing some customers going from spending maybe a $12 million a year just processing text files to less than 100,000 right now. So what are the drivers of creating an LLM-based application? It would be you have a user input that you provide to some sort of a web app UI that could also be in form of a chatbot or maybe just a custom window that you create within an organization. It connects through a fast API to an NLP or an AI engine that is developed inside a Langflow environment. And within that Langflow environment, you will have all of these components that you could directly integrate into a pipeline. So you could have an OpenAI embedding, you could have a vector storage that stores all of that embedding. You can create your own organizational custom functions and upload the document base or the knowledge base from your organization to support the extract from this model. And if you just use all of that information within the organization, it might do wonders for you if you are dealing with thousands and thousands of documentation. And that brings me to the next one, where we'll explore how a Langflow process would look like in real world if you are creating a RAG application. And here is a schematic that I have for you of how simple it has become to create a RAG model into your organization. And I'll just quickly walk you through this process. So the first thing we are doing here, we're taking a chat input from our user base or maybe somebody who wants to actually generate insight from the data. We put all of that input and an embedding into a vector store, which is a pre-trained custom database storage from data stacks such as AstraDB. All we're doing is giving a database token, an API token, and it does everything in the backend. We're also giving it the knowledge base in form of files that are available within the organization or in form of a web URL that it could just go and parse through in real time. So if there is something that is updated on the website, it could directly extract all of that information. And then we are putting all of that into a vector database store here. Once all of this information is available in this vector database store, they are nothing but numbers. So now you support all of that through a prompt and move all of that information through an OpenAI API interface. Now, OpenAI, what it would do, it would use its existing billions of parameters that it has been trained on, if we talk about GPT 4.0, but it will also be now supported with your specific custom data that you want to generate insight from. So the engine remains the same. All we're doing is we are enabling the engine with custom data model or with custom data information from our organization. And we are just getting a chat output from this data. And this is the kind of extent that innovation has gone into, and then we have really pushed boundaries in the organization, creating chatbots, creating multiple use cases within our productionized system in the organization, and we've actually deployed this for enterprise customers as well. So, and all of this you could understand or do maybe in a day's time if you understand all of this pipeline. Obviously, the most productionized version would not look as simple as it looks now. It would be maybe 10 times higher in complexity, but the number of iterations that you will have to do or the time to market is going to significantly reduce, and the cost will reduce as well. And now I'll just introduce with some use cases that we are seeing that are actively gaining traction in the market is virtual assistants. So maybe you don't need an HR vertical within your organizations because you've got all the SOPs and processes now clearly integrated into an HR system that anyone can query and get information from. You can answer, you can do Q&A from your rack systems. You can also do content creation. So if you have already 10 or 20 people marketing team within your organization that are writing and posting content related to your organization, all of that can now be automated through an AI agent that is now more heavily customized for your use case. Medical diagnosis, we all know, is gaining a lot of traction. We are seeing more innovative ways to solving medical problem, code generation, sales automation, and then there are many more as well. The most important one that we have been using right now is in product development, because we are driving a product that has to scale and scale fast. We cannot spend a 6 months time to generate an innovation and then after 6 months time come to a realization that nobody actually wants to use our product, which means if we can generate the insight beforehand, can understand where the most amount of organizational revenue and effort should go, and develop a product that scales, is productionized, and is acquired by our customers, that's the most amount of value we want. We don't want to generate or develop something that nobody is actually using in 6 or 1 year's timeline, and we are sitting on a very big sunk cost that now a steering committee is really pushing us for. And these are some use cases for RAG that we are seeing in the market. And that's it for my time, and I will be open to taking some questions if you have any. Okay, so if there are no questions.
Thank you, Sapnil.
Thank you, Sapnil, for introducing the long flow environment to harness unstructured data into a vector representation for the usage with the RAG workflow. Probably if you would give one or two insight with respect to the use cases. Probably you mentioned about the medical diagnosis or financial flow. So how this long flow or any other database tools that is used with the RAG models to generate the data set finally from the structured to the unstructured one. Is it possible to provide one use case with the simple examples?
For sure, for sure. Yeah. So I'll give a quick background, and maybe I'm getting a little bit of echo from the room. Okay, so I'll give a quick example from the business that I'm working on right now. So we are currently scaling this product for a client, Pfizer. And what they do usually is they want to create, or maybe they process maybe 3,000 medical cases onto their product platform every day. The cost to process one case is $10, which means they process 3,000 cases, $10 a case, which is $30,000 a day. Expand that into a month's time, we are looking somewhere to the range of $1 million just in case processing. There is a lot of work that goes behind case processing of having medical reviewers, medical assessors, and doctors to write doctor's note, do research on the medicines that they have surfaced into the market, and there is information that spans across the entire drug discovery life cycle. So from phase 1, phase 2, and phase 3 clinical trials to actually looking at productionized drugs that are being used in the market for 20 odd years now. We have also seen an example of some coronavirus vaccines that Pfizer came out with going horribly wrong in multiple geographies. All of this needs to be reported to medical agencies, and these medical agencies now take a decision for the drugs that are available from a particular supplier, whether these drugs are efficiently working to the best of the standards that the organizations are claiming in, or they would want to go ahead and penalize these organizations and shelf the drug. Now, how Pfizer is benefiting from this is they're getting all of this information beforehand. So before anybody reports adverse events from their drugs, they're able to generate all of this information right during the drug discovery or the clinical trial phase itself. They've got thousands of documentation and patient case studies that they pass through during the clinical trial phase, put all of that information to a custom RAG model. And this is not going to be a RAG model which is so simplistic, it's more tailored to a particular data set that spans across lakhs of parameters. And then they generate an insight beforehand in their drug supplying process. So before an adverse report of this drug goes to health authorities and their drug, and then the risk the drug getting shelved and taken off the market, they can generate all of that insight beforehand and take those corrective actions beforehand before investing millions of dollars in this drug discovery process. The other use case we see specifically in the product team that I sit is that we've got a product development lifecycle that's been running for 5 years now. We've got 10 product managers that have joined the organization, that have left the organization. All of them had different ways of working and operations historically, and those ways of operations have changed over time. To actually understand what used to go in an organization or in the product development phase 5 years ago, what worked then and what's not working now, this is very important. This is really helping us do all of that information synthesis and information processing right through an interface that we are now developing in form of a chatbot within our existing organization. So these are like some 2 high-level use cases that I could think of.
When you mentioned about this insight being created with these models, and also mentioned about the self-learning or the changing patterns over the years. So it would be a continuous process of generating the insights?
Obviously. So we basically focus on quarterly model training, which means we are not doing a model training every month or every 2 months. We focus on a release cycle mechanism. So our product releases every 6 months, an update to the product goes every 6 months, but we train our product models every 3 months. So there's a specific learning curve and a glide path to getting that insight on a quarterly basis.
Thank you very much, Mr. Bhatnagar. I didn't get the previous slide to this. Can you just explain that? What is that previous slide? Yes, this one.
Do you mean this one?
Yes.
Yeah. So this essentially is a line flow environment. Let me do a quick expansion of this environment for you. Yeah, so this is a terminal where a RAG model can be created that it can extract information from text files, PDF files, or URLs, or maybe an audio file, whatever embeddings that you use.
Any other questions from the audience or the audience online? Thanks a lot, Sapnil, for addressing us and providing an very insightful session on usage of the LangFlow for the RAG workflow models. Thanks a lot from the Mangalore University here and our ICRAI conference part. Thanks a lot.
Thank you. Thank you very much. Thank you for listening to me and having me today. Thank you.
So on behalf of the organizers, I thank Professor Uday Kumar Chennai for chairing the session and taking the questions to Sapnil and getting it answered. Thank you very much for chairing the session. Thank you so much. So it's 3:30 now. We'll break for a short while and then we'll come for the concluding session at 4 o'clock. Okay, tea will come, so you'll all have tea and then we'll come for the concluding session. Okay, yeah, here only. Thank you.
Are you ready? Yes. Keep it. Is your supervisor? Okay. Today only you are coming. No, review sir. 1 is over. No, that was pending. Review 1 is pending. You told after review 2 you will do. This is review 1, na? This is second review. Second reviews. Have you discussed with your supervisor? Yes, sir. She told her she is little busy, but I have told her. At least take a hard copy, submit it to your supervisor. Yes. Supervisor has to go through it, get the sign, then come back. Yes, sir. Sir, until then? After that, you can give the presentation. Okay. But because without supervisor, I will not allow. Okay. Even she is busy, she has to sign it. She told last week she was full busy, sir. This maybe last working day. Exams. At least you have a discussion with the supervisor. Yes. At least you submit the hard copy, she will give some suggestion, then you can come for the presentation. Okay.
So what about review 3, sir? Same thing.
Full. Have you completed full
Yes,
project?
almost.
Then complete it with the report. That's it. Full report I need. Yeah.
Sir, but review?
I will consider it, no problem. But without the sign, how I will consider?
Okay, sir.
Okay.
Thank you, sir.
Thank you.
Sir, if they schedule review 3, can I attend review 2 first?
No, complete. First we'll complete at least review 2, then we'll go for review 3.
For completing review 2, my guide need to sign on the hard copy.
Yeah. Without her knowledge, I will not conduct.
Yeah, sure.
Yeah,
She told she was busy.
Yeah.
Thank you, sir.
Thank you.
2 enriching days of intellectual exchange, engaging discussions, and the exploration of groundbreaking ideas, we are now at the moment of reflection and closure. As we conclude this remarkable event, let us take this opportunity to celebrate the success of the conference and recognize the efforts of all those who made it possible. To begin with, let us invoke the blessings of the Almighty. I invite students of Department of Electronics to lead us into prayer.
जय गणेश जय गणेश जय गणेश पाहि मा जय गणेश जय गणेश जय गणेश रक्ष मा जय गणेश जय गणेश जय गणेश पाहि मा जय गणेश जय गणेश जय गणेश रक्ष मा मुदाकरात् मोदकं सदा विमुक्तिसाधकं कलाधरावतंसकं विलासिलोकरञ्जकम् अनायकैकनायकं विनाशिते वदैत्यकं नताशुभाशुनाशकं नमामि तं विनायकम् नमामि तं विनायकम्
Thank you, students. I now invite Professor Naveen Kumar SK, Organizing Committee Member, ICRAI 2024, to deliver the welcome address.
Good evening, one and all. Today we are in the end of the ICRAI 2024. I hope all of you enlightened from this conference. Now we have a valedictory function. We have two guests. Sri K. Raju Magavira KS. He is the registrar of our university. He is an alumni of our university. He has done his MBA in this campus. He is an efficient officer and supporting all the academic activities in the university. Actually, what the lab you are seeing today, this Center of Excellence, Professor Raju Magavira, our registrar, supported lot of things while initial stages. What are the things he is seeing outside the classes? We requested him in his last tenure. He granted all the things what we are requested. And he is prior to coming to this university, he has served in Udupi, Dharwad and Bangalore in various designated in government of Karnataka. On behalf of all, I will welcome Raju Magavira sir for this valedictory function. And one more guest, Professor Manjaya, is a Dean of Science and Technology. Right now he is serving as a chairman of the department and also senior professor. He published more than 200 papers. He is a recognized, renowned researcher. If you go any part of India, Professor Manjaya name is familiar in computer science department. Recently I went to Goa and most of the professor asked me, Manjaya, he came regularly for the exam and other academic initiation, and also he produced more than 40 students, I think so. I don't know, sir. More than 20 students in the PhD. A number of papers presented in international and national conference. Welcome you, sir, this valedictory function. And I'll also welcome Professor Khan, Senior Professor of Department of Electronics. He is the main and this one pillar of this conference. I think he succeeded. I think we have to thank him because he done this successfully this conference, and also Professor Shekhar, Computer Science Professor, Senior Professor, for this valedictory function. Thank you, sir, for coming.
Thank you, sir, for the warm welcome, and a warm welcome to you, sir. Before we proceed further, let us extend a warm welcome to the dignitaries. I request Professor Naveen Kumar SK to florally welcome our chief guest, Sri K. Raju Magavira. Thank you, sir. I request Professor A.M. Khan to florally welcome Professor Manjaya D.H. Thank you, sir. I request Dr. B.H. Shekhar to florally welcome Professor Naveen Kumar S.K. and Professor A.M. Khan. Thank you, sir. A warm welcome to Dr. B.H. Shekhar. I request the research scholars to welcome the dignitaries of the dais. Thank you, madams. I would now like to call upon Dr. Manoj Gadiyar to share your feedback about the conference.
Good afternoon, everyone. Yeah, good evening, rather. Yes, right. So, dignitaries on the dais and off the dais, it's a time to give feedback to the program. Whenever we speak about any conference or any workshop, there are two things. One is knowledge, another one is connect. So, this conference has witnessed both when it comes to me. I am not introduced to, I'm not a frequenter to Bangalore University. But I think in future I'll be frequenter because of a very good association now with Dr. A.M. Khan sir as well as Dr. Shekhar sir, who are the organizers of this workshop. They're very well organized right from the first day when we had come here. We are the co-host at the same time, but we felt that we were taken care very well, sir. Thank you for that. So right from the time we have come here and till now, we witnessed not only the hospitality but the oneness among all the faculties here, and at the same time, I got a very good connect. Professor UC Niranjan sir, I got his connect today. Dr. Likha, Dr. Vibhushine, and Abu Bakr, I got to know him also. And a very good cluster of people with whom I can interact in future. And this workshop, this conference has witnessed a lot of knowledge transfer. And there is a lot of knowledge transfer, and I have noted down few points. And also now Khan sir is planning for the Center of Excellence, and thank you Registrar sir for even supporting us and helping us with the MOU. And Manjaya sir also, I expect a full support from you, and we can work in collaboration. So the overall feedback is, I felt very happy. I did not feel that it is 2 days. I felt it's as if it's 2 hours. And if it was still 2-3 days, I would be a part of it. So overall, thanks to Bangalore University, Vice Chancellor Professor Dharma, and yesterday for his exemplary speech, and I have become a very good fan of him as of now. And thank you for from the part of Canara Engineering College. Thank you. Yes.
Thank you, sir, for your valuable feedback. I would now like to call upon Dr. Lika Nawaf to share your feedback on the 2 days conference.
everyone again. Actually, it's a good time to spend with you guys, and I'm really happy to collaborate and to meet new people of India with different titles, professors, associate professors, and hopefully for the future we will do a lot of collaboration. So that's in terms of interacting with Mangalore University. In terms of the conference, I've seen a lot of good papers. It's a good outcome, but I might advise to all the students and the authors to concentrate more on the contributions. I've seen that most of the students, they concentrate, maybe it's just the beginning for your life of research, let's say, the beginning journey, but I do advise you to concentrate more on the contributions, because this is your target for research and for work. And well done for all the authors, and I think it's really good conference and good collaboration. Well done, everyone. Yeah, thank you.
Thank you, ma'am, for your valuable feedback. I now call upon Dr. Vibhushani to share your feedback about the conference.
All right, so good evening, everyone, and thank you so much for giving us the opportunity to share our feedback. I know Dr. Manoj and obviously Dr. Lika covered most of the stuff, but I would like to start thanking the Mangalore University for hosting this conference. As Dr. Manoj clearly said, I think this is a great place to share knowledge as well as to connect with other scholars, researchers. And also I would like to thank Cardiff Metropolitan University for co-hosting this conference, and of course the registrar for helping the staff members to signing the MOU as well. So, so obviously at the start yesterday, chief guest, vice chancellor, and also we had set of speakers, and I personally did really enjoy their speeches. I felt like it was not a speech. It was for me like a motivational talk, and also the one thing that they did highlight was the responsible or ethical use of AI. I think that is probably the takeaway from this conference as well, because I mean AI is going to stay there and we're going to use it, but you need to make sure that you use it in an ethical or responsible manner. So coming to the presenters who did present their work, well done everyone. Probably this might be the first time for you. You have done a brilliant job, but I know Dr. Lika did touch a little bit about the contribution, so that bit was a little bit missing, especially for those who are planning to, or those who are doing the PhDs. The other thing what I felt was, some of the presentations, they had a lot of words. So for us, like rather than listening to the speaker, we were tend to reading the slides. And also some of the students, they present really good statistics. However, because we collect data, but data integrity, data accuracy is very important. For me, I felt like it's not your mistake, but if you had given the in-text citation, it would have been better, because then whoever who reads the slides and they know, okay, so this is where they got the data. So this is a small advice, because I have been through the process, very recently. So yeah, just a piece of advice. And the second day, again, amazing presentations, and obviously we had great talks as well, very contemporary talks. So thank you so much for the contribution, and thank you again for Professor Khan and everyone for having us as well from Cardiff Metropolitan University.
Thank you, ma'am. I would now like to call upon Sinchana to give your feedback about the conference.
Good evening, everybody. I'm Sinchana from PA College of Engineering. I would like to thank everyone to organizing such an event. This is my first time attending the conference here, so I'm very happy to be part of this event, and I learned so many things from the event, so many teachers over here for me. you taught so many things for me. I would like to participate in the event in the future also. Thank you everyone. Thank you all of you for organizing such an event. Thank you.
Thank you, Ms. Sinchana. Next, it is my privilege to invite our chief guest, Shri K. Raju Mogavira, Registrar of Mangalore University, to address the gathering and share his closing thoughts on this conference.
Good evening, everyone. Respected dignitaries honored of the dais and my dear friends. In fact, in this hall, I am the only person, I believe, who doesn't have a doctorate degree or who cannot be called professor. And basically, I am not even a student of science. So I don't know how much I can speak on a technology like AI. Anyway, recently I watched a movie called CTRL. I'm not sure how many of you have watched. It's in Netflix. In fact, I did not know what CTRL mean when I just saw the movie title. Simply, just for time pass, I just saw the movie. And after a few minutes into the movie, I came to know about CTRL means it's control, it's a computer language. Then I simply so it's a simple movie, not a great movie. It doesn't have much message or anything like that, but it's a watchable movie. So it's the storyline is like this: two social media influencers, a couple, they break up, and the girl wants to delete every memory of her ex. And she takes the help of an AI app to delete his memory. So she goes into the memory and deletes his pictures, his video. Only his portion is deleted and hers remains. So, and she succeeds. But it happens in such a way that after a certain time, rather than the app becoming a tool for her, the app becomes the boss and she becomes a tool. And in a nutshell, this speaks about the ill effects of AI if used in that sense. So as a user of AI, what I want from scientists like you, from talents like you, from developers like you, a tool which cannot be misused, a tool which will not poke its nose in others' private affairs, a tool which will not disturb or destroy the human capability. But having said, all the tools, all the great tools, all the great inventions, all the great research might be used or can be used for both good and bad purpose. The greatest invention of humankind, when we speak of the early human history, the wheel is called the greatest human invention. But a wheel can also be used for destructive purposes. Till 9/11, if I'm not mistaken, the Twin Towers of New York, till 9/11 happened, we never knew that an aeroplane can be used for destructive purpose. Nobody thought that, even Wright brothers did not imagine that an aeroplane that he was imagining, he was dreaming, could be used for a destructive purpose. So whether we use a particular tool or a particular invention or a particular instrument for good or bad, ultimately rests on the person who uses it. So if we keep this in our mind, then I think we don't have to worry too much about the AI being ruled or AI taking control of human affairs or our future. Anyway, the apt title, Responsible AI, of course we need to keep discussing, because it's an evolving science and we never know how it is going to help us or how it is going to create problems for us. But there are efforts to keep it in a limited ethical or legal sense, to bind it. But again, it's a subject or it's a field which is too vast. I don't know how far we will succeed. I am for one who believe in the human wisdom or the basic goodness of human beings. So in that sense, if we think properly, every user, of course there will be some misuses, there will be some losses, there will be some heartbreaks, but at the end of the day, if we can use any technology for human good, I think that's going to help us in the long run. Because we cannot shut our eyes that no, AI can be used in a destructive purpose or in a negative sense, so we cannot use AI. No, we cannot say that. Because even if you take the example of India in the 1970s or early 80s, when computers were being used in nationalized banks, there was a big hue and cry. People who are in our 40s and 50s know how much agitation was made by these trade unions supported by political parties. Everybody was thinking that by introducing computers, the computers would snatch away our jobs and everybody would be jobless, everybody would be in the street. Nothing happened. In fact, they began a different revolution. In the same way, AI can usher a new revolution in our thought process, in the way we work. If you take the example of Fortune 500 companies, there are great companies. For example, take Meta, take Alphabet, take Facebook, take Tesla. Tesla, all of us know that Tesla is a car company. But is Tesla a car company in its real sense? Is it like, can we compare Tesla to our Maruti or Tata? No. Tesla is basically a technology company. Tesla uses the basic AI concept, the AI intelligence. So that gives an idea that the AI is the future. If we remember that, then we have responsibility as well as we have hopes in the best use of AI. With these words, I would like to thank the representatives of Cardiff Metropolitan University who have come all the way from England here. And I remember the day when on behalf of Mangalore University, we signed the MOU with Cardiff, and we were expecting for this seminar. I think I must thank Professor Khan and Professor Shekhar for organizing this international conference on responsible AI in a very, very professional way. I am really happy that you people gave good feedback, and this is the first step. Definitely we will have a series of interactions, conferences like this, and Mangalore University will definitely going to support this type of cause, because this is the area, this is the field that all of us have to involve ourselves, because by involving like this and conducting conference like this, we will learn, and that's good for an institution like university or a college. And already we are talking about and having a cluster of colleges as partners. I think we will have a lot more busy days in the coming days. With these words, I would like to stop here. Thank you very much. Yeah.
Thank you, sir, for your enlightening words and for inspiring us to continue working towards responsible AI. It's now my honor to invite Professor Manjaya D.H., Dean, Faculty of Science and Technology, to give the presidential remarks. Over to you, sir.
Very good evening to all. Respected our beloved Registrar, being the chief guest of the ending ceremony of the 2 days very knowledgeable international conference on responsible artificial intelligence. And two of the icons, my colleagues Professor A.M. Kanji and Professor B.S. Shekhar, and head of the department Professor Naveen Kumar, respected audience, experts, ladies and gentlemen. First of all, I would like to congratulate them, and also I am very thankful to the feedback of our Cardiff Metropolitan University professors as well as jointly organized Canara College faculties ladies and gentlemen, way back 5-6 decades back, person does not well versed with the computing paradigm, you have to treat him as illiterate. Today is you have to be 360-degree angles, you have to get through the technological event, because commonly usable machine is an optimal one, is a materialistic one, is a performance one, highly universal one, taskable one, time sense one, and finally number of resourceful which are available from the man-made machine. Because how we can highlightening, like in which way the God internet is going to be provide a service to us, and you have to be enumerate, find out the level of services which are there, but we are not going to be creator or like a miracle representator, but you have to do some good work. This type of a international conference, which are glimpse for us still further, you have to be alert ourselves, what are all the challenges in front of, and because after studying a computing paradigm and see the buzzwords of different paradigm, like beginning from digital, maybe a data, it's an intention, it's a globalization, it's a technology, it's an automation, and finally least cost and high productivity, digital technology. Ladies and gentlemen, but we are, main resources are available in this district especially. Around like 7-8 medical colleges we have. Because once you are seeing like a number of data, basically the artificial intelligence is presently the application oriented, not 24 level, more than that one, but 360-degree angles we can get an application. What we are observing, we can say all-in-one is an artificial intelligence at present. We can make sure such a way that how best way. Certainly, some of the standard applications which are available like automation, building automation, weather forecasting, and agriculture application, none other than what the fraudness, attacks which are going to be happen, which are highly security. You can take a pentagonal way of the objective of the security, like you can look at like what is meant by confidentiality, integrity, authentication, authorization, and finally auditability. These are the 5 important application oriented which are going to be gained much more. Of course, this type of the way of the involvement of all of us, because in which way can come across within the 24 hours, it's not possible to gain lot more. Knowledge is a power, knowledge is correct, no, lighten. We can make sure such a way that how best way we are taking all which are going to be footprint for the further, because still further number of applications I mentioned very clearly, especially for the medical application related image processing, even available number of type of data which through, you can say especially one of the standard application of the AI is generative artificial is basically making use the applications of the machine learning with the help of standard data, maybe a text oriented, maybe a model oriented. You have to make your standard algorithm, and finally gain, you have to create a realistic type of a problem. That is called generative AI. Basically, you think about, is it possible to make use a standard set of a data which are available, because various application oriented, is it possible? Those are the problems and the challenges in front of us. You think about, because these are all only how we can share and how we can get an idea from the within a short period from the great resource person of this conference, correct? No, probably you got through the offline as well as online and virtually also, just for the glimpse of us, the knowledge we can be able to create. And first of all, once again, I'm very thankful to our administration authority, Honorable Vice Chancellor, as well as the beloved Registrar, providing all sort of support, because in which way can we further, we can plan. Because of your cooperation, within a short span of a time, we made it very clear. Is it not possible, short span of a time, the international conference which are going to be gathered, but international conference is going to be correct. No, getting the people from the international is very difficult too. But anyway, virtually, most of the papers which are ventured through that one, virtually, somewhat correct. No, clearly got it, some idea, problems which are there, enhancement of the thoughts provoking ideas you have to be think further, is it possible to gain knowledge? And once again, all the parts who are all coming all the way from the different countries and different places of the continent, and finally make this very useful and fabulous and fantastic of this program. I'm very thankful to each and every person to responsible. The conference is going to be international conference responsible for AA, and each and every persons are responsible for make this conference very successful, and congratulate both of the pillars, especially Professor A.M. Khan and Professor B.S. Sekhar and team of the all together once again. And I would like to give some of the problems, because once you say the medical application related, here 7, 8 medical colleges around, because once you are passing from here, go to the city, you can see 3, 4 medical colleges are there. And need not to be referred like a open data sets, correct? No, you can see the data sets which are available realistically. Is it possible to take a problem? You can think about, because you have to be in which way you can find out the problems of the society. That will make somewhat different step. We have to be think in a positive manner. Obviously, you can get a better solution for any type of a problem. Once again, thank you one and all providing me the addressing of the presidential address of this. Finally, the concluding remarks of International Conference on Responsible for Artificial Intelligence. Thank you one and all. Jai Hind, Jai Karnataka.
Thank you, sir, for your thoughtful words. As we approach the end of this session, it is time to acknowledge the efforts of those who made this conference a grand success. To deliver the vote of thanks, I invite Professor A.M. Khan, Convener ICRAI 2024. Over to you, sir.
Good evening, everyone. Respected Chief Guest of the program, our Honorable Registrar, Sri K. Raju Mogira, KS, President of this program, the Dean, Faculty of Science and Technology, Professor Manjaya, the Chairman, Department of Electronics, Professor Naveen Kumar, my friend, co-convener, Professor B.H. Sekhar, our senior advisor and motivator, Professor U.C. Niranjan, Captain Vas, Albuquerque sir, research scholars, students, online, offline, faculty from Canara College, the support of this conference, to distinguished guests from UK, Cardiff Metropolitan University, ladies and gentlemen. It gives me immense pleasure to propose the vote of thanks at the end of this 2-day international conference. We don't know how the time flew away. Since 9:30 yesterday morning, though the last 2 days before we approached the conference were sleepless, but still, time just flew away. And I'm surprised I'm standing here to thank all of you who have helped in organizing this conference. It was very nice having received 80 papers for, and that too in an area of AI. We are very pessimistic about that because AI is not that much developed as far as research is concerned. But we could get 80 research papers for review. Springer had approached, we had approached Springer for publication, thanks to Professor Chaminda from Cardiff Metropolitan University, UK. Springer agreed to publish 35 best papers. So after review, we could shortlist 30 number of papers for presentation and publication in Springer. Apart from those 30, we had around 27 participants registered as participants in this conference, both online and offline. Overall, the conference was very good, starting from the right go, which gave the tempo of what is responsible AI, how AI should be used in the inaugural address, to what our registrar told today, giving the say example of a film, how computers could be used. And one best example of that CTRL film, which was very interesting, and how I could really imagine how AI will kill a man. But it's nice to having seen those examples. Our president of this program also referred to generative AI. In the days to come, very soon, in about 1.5 to 2 years, we will be having a center of excellence for generative AI on our campus. So that will lead to many more research happening in this particular field. So let me proceed to thank the chief guest of our today's program, Professor Sri K. Raju Mugavira, for all his support and for his kind words during this valedictory program. Thank you very much, sir. I request Professor Shekhar to hand over a memento to the chief guest of today's program. I deem it a great pleasure to thank the president of this valedictory program, the Dean, Faculty of Science and Technology, my friend Professor Manjaya, for gracing this occasion and giving motivating words to all the researchers of how they can plan for research in future. Thank you very much, sir. I should thank my colleague and the chairman of the department, Professor Naveen Kumar, for all the support from the department in organizing this conference. Thank you very much, sir. A special thanks to Karnataka State Higher Education Council, Bangalore, Professor S.R. Niranjan and his team for giving us an opportunity to sign a MOU with Cardiff Metropolitan University, because of which we are here. It was way back exactly 1 year ago in December last when we approached, when KSHE asked us whether we would like to have collaboration with UK universities, and we said yes to it. And that's how the MOU came up. The first phase, 2 scientists visited us. 2 more scientists are here to talk to our students tomorrow and day after. Along with that, we have been organizing webinars, and now this conference is going to happen. I hope in future, every December, we may have a ICR 24, 25, 26 and onwards, with the help of all the cluster colleges, Canara Engineering College, Sahyadri Engineering College, then BIT and PA Engineering College, along with few more who are ready to join us. One from Ahmedabad, if I am not wrong. Presidency University, Raichur University also want to join our cluster. So with a cluster like this, that gives us for more collaborative work, collaborative joint projects, and a lot of research to happen in future. So thanks to KSHEC, thanks to Cardiff Met for accepting our partnership under Karnataka Wales Partnership Program and signing a MOU with us, especially Professor Chaminda Hiwage, and then Professor Angesh Anupam, who came here during the signing of the program. Thanks to Cardiff Met, all the officials and governing council of Cardiff Met, the British Council, if I am not, Bill Burson, who recently had an online meeting and said we can go ahead with the project even in the second stage. Thanks to Honorable Vice Chancellor Professor P.L. Dharma for giving us all the freedom to organize such a program on our campus. I also thank our Honorable Registrar and the administrative staff, each and everyone who cooperated with us and helped us in organizing this program and making it a grand success. Thanks to the Departments of Electronics and Computer Science, my colleagues in Department of Computer Science and Electronics, who helped us in organizing this program as the organizing committee members. If I will be failing in my duty, if I don't thank my co-convener, my friend Professor B.H. Shekhar, who toiled with me day and night in the last week, because we're not sure about getting the papers. The papers, as you know, the data, like our UCMS, not in our hands, but the data was all in Springer. We could not get the data still. The abstract of each of the paper to be collected from them, putting them in one format, organizing them as first session, second session. So that way, yesterday it was totally offline, everybody was here. Today it was totally online, though it was a packed room, but everything was, we could see only the screen, except for Professor Niranjan, who spoke to us live here. I think students must have been motivated with Professor Niranjan's talk today. So that way, it was a nice thing. So I thank the engineering department, my friends in the engineering department, for giving us all the support in terms of electricity and other things for arranging the program. Then I should thank the staff of IBM Center for helping us here, all the members of the organizing committee. I should thank Professor Chaminda and Professor Angesh for the paper reviews, 80 papers to be reviewed, and 4 or 5 people only doing their job, including Professor Shekhar, myself, Professor Angesh, Professor Chaminda. It was a tough job there, but at the end, when the second review was to be done, Professor Angesh and Professor Chaminda helped us much there. Then I should also thank Springer for agreeing to publish all our papers. It's a very good high impact factor journal. So I thank them. I should thank the technical staff of computer science, especially Mr. Vijay, Mr. Ajay, and Mr. Anand, who are here. Day and night for the last 4 days, they were testing the cameras because it was a live conference. First of its kind in Bangalore University, where things were live. You could see today somebody was speaking at Bangalore. The chair was sitting in UK, and we were listening here. And it so happened that one of the paper was being presented in some Middle East country. Today we saw one paper. The chair was from Canada Engineering College sitting here, and another chair was in UK. So it was nice, say, multi-place, multi-modal, hybrid mode of conference that we organized for the first time in Mangalore University. I thank my technical staff, Mr. Vijay, Mr. Ajay, and Mr. Anand for helping us in organizing this program. I should thank the research scholars of computer science, Mr. Vanur, Shazia, Rashmi, and Vidya, for being with us throughout and helping us in organizing the things, arrange the things in proper way. I should thank my research scholars, Mr. Narayan Prakash, Pratibha, and Vijay Lakshmi, for being with us throughout, looking at every final details of organizing the things. Thanks to my students of Department of Electronics, those students of PA College of Engineering, for being quiet listeners who could get more knowledge, and your presence here also gave us the strength. I also thank all the distinguished invitees, especially Professor Niranjan. Though he finished his talk early, he stayed with us throughout. And even when we thought of organizing this conference, the first person I approached was Professor Niranjan, asking him for whom should I call as invited speakers for this particular conference. Professor Niranjan suggested 2-3 names. Two of them, one being in the US, Prithviraj, he said my timings will not be suitable for your talk. However, one of the person agreed, and Sir himself was there today to motivate us with telling about what are the opportunities in AI. And I thank all of the invitees. I thank all the 6 keynote speakers we have been hearing since yesterday. Professor Niranjan was one of them. Professor Samiruddin Khan from Presidency University, you heard online today. Then Mr. Mike Edward from BSI, he was online telling about the regulatory, ISO standards for artificial intelligence. Then we heard Professor Zhang. Then today afternoon, we also heard Samir Bhatnagar from US. So that way it was a very good conference, having heard all of them. So 6 keynote speakers, 3 of them were here, and 3 were online. Along with that, all the people who presented their papers, the research publications, whatever form they were telling. And I should thank all the chairs who chaired the sessions. If I can name a few, Professor Uday Kumar was there, Uday Kumar Shanai was there, Professor Prahash Amin was there, then Professor Manjaya was there, Professor Naveen Kumar was there yesterday, and then Manoj Gadiyar, Dr. Manoj Gadiyar was there, and then Dr. Praveen Raj and Gopal were there today. So many other chairs who chaired all the sessions and helped us in conducting the conference very nicely. And I should thank my friends in the press who have given wide publicity before the function yesterday. And then today they have covered nicely about the inaugural program also. Thanks to all the friends in the press and all those who helped in success of this program. I thank all the persons who have directly or indirectly contributed for the success of this program. Thank you so much, and thanks everybody for giving me this opportunity to organize such an international conference in the university. I should be thanking the PM Usha scheme also, because there is where lies the financial support which helps us. A big amount of money comes from that. Our registrar agreed to sanction money under that scheme so that we could organize this conference. So I should thank the Government of India also for giving that scheme to us. And thanks to each one of you. Thanks to all of them who supported me in organizing this conference. Thank you one and all.
A big thanks goes to you too, sir, for being a great convener. Thank you, sir, for the comprehensive report and for the heartfelt acknowledgement. With that, we formally conclude the valedictory session and the 2-day international conference on responsible artificial intelligence. On behalf of the organizing committee, we thank each one of you for your participation, enthusiasm, and valuable contribution. We look forward to seeing you at future editions of this conference. Thank you and have a wonderful day ahead.